Faced with uncertainty in the future, refineries have to build resilience with agile decision making, virtual scenario planning, product price benchmarking, and streamlining workflows to approve decisions in remote work setups. Now, COVID 19 has given the push comes to shove moment for refiners adopting digital technologies to stay ahead and remain cost competitive. Our first technical session will focus on Downstream 4.0, smart manufacturing and digital transformation. Please welcome our speakers. We have with us Mr. Tapish Pramanik, Vice President R&D and Innovation, HMEL. Please welcome him. He will be chairing this session. We're also joined by Tommy Kurz, Senior Director, Solutions Consulting, APJ Aspen Technology. He will be speaking about G-Dot production optimization. Please also welcome Mr. Saurabh Dayal, Client Account Lead, Energy Accenture. He will talk about digital compass to navigate the ONG sector. And we have Mr. Kunal Dikshit, Manager DuPont Sustainable Solutions. He's going to give us a presentation on mindset and culture for adapting to the new reality. A warm welcome to all of you gentlemen, and I'll hand it over to you, Mr. Pramanik.
Thank you, Alicia. Good afternoon to my distinguished guests, delegates, colleagues, ladies and gentlemen. I'm glad to start the first technical session of GRPC 2020. The session theme is Downstream 4.0, Smart Manufacturing and Digital Mission. For this session, we have three accomplished speakers, Mr. Tommy Kurz, Mr. Saurabh Dayal, and Mr. Kunal Dikshit. Before inviting them to make their presentations, I wish to set the context for this technical session. The topic for today is very relevant as for the downstream sector, as all entities involved are finding ways to leverage digital technology to improve performance, optimize efficiencies, reduce costs, reduce impacts on the environment, and have a positive impact on society. When I joined the downstream sector in HPCL 4 decades ago, the world was already in the industry 3.0 phase, and I was fortunate to be witness to the Indian refineries moving into the digitization phase with the shift from pneumatic instrumentation to distributed control systems. Since then, the Indian downstream sector has rapidly digitized, keeping pace with the global downstream industry. During the last decade, the downstream sector has entered the industry 4.0 phase by embracing IIoT, artificial intelligence, cloud computing, big data, machine learning, etc. This session speakers will definitely highlight solutions for digital transformation which are presently available and will be available in the near future. With these remarks, I now would like to start the session by laying out the ground rules. This session is of 1 hour's duration. Each speaker will have 15 minutes, and with a grace period of 2 minutes. The last 5 minutes we will keep for the question and answer session. So now I invite Mr. Tommy Kurz of Aspen Technology to make his presentation. Over to Tommy Kurz.
Mr. Pramanik, thank you very much. Good afternoon.
Yeah. Please go ahead.
Yeah, good afternoon, everyone. My apologies that I cannot be on camera today. I have a little bit of an infection in my eye, and so I prefer to keep the camera off, and I thought I'd let everyone know. So let me share my presentation with you. Okay, is this happening? All right, hopefully everyone can see my presentation coming up. Good afternoon. It's a real pleasure and an honor to be here today. My name is Tommy Kurz. I'm the Senior Director for Solution Consulting Aspen Technology, and I'm based in Singapore. So just a brief background. I'm in the industry now for more than 20 years. I started many years ago after graduating from Delft University in the Netherlands. I started my career with Unilever, famous food and beverage. I was active in the specialty chemicals. And after which I joined BP after several years when Unilever divested their specialty chemicals. And at BP, I've worked many years in the flagship refinery in Rotterdam. And I covered many roles during my period, from commissioning manager to process engineer on the units. Um, and after which, after my BP period, I married a Singaporean lady. So I moved countries, came to Singapore, and I started consulting work for a company called KBC Advanced Technology, where I worked many years on KBC's advisory services for profit improvement and troubleshooting all across Asia Pacific. As some of you may know, KBC was acquired by Yokogawa Electric, and that was a turning point in my career as well. So via Resources to Energy, I joined Aspen Tech, and I'm very excited to be with Aspen Tech and on our digital transformation journey. And I've been with Aspen Tech now for more than a year. So I'm very proud to be here today. At Aspen Tech, we have a history of innovation, almost 40 years. And today I'm going to share with you all specifically our production optimization stack and our dynamic optimization, as well as driving uptime with prescriptive maintenance. Okay, and I've done my bio, so it's included in the deck. You can read up. So production optimization, it comes with challenges. We interact with many customers, on a global basis and also on a regional basis. And from these interactions, we have formed a consistent view on some of the commonly encountered challenges that we see specifically in this extreme volatile situation that we are experiencing globally due to the COVID crisis. Hopefully you agree with these challenges, but let me just sum them up. Margin loss often is due to misaligned business and operating processes. Secondly, we often see that process units may not always run at their limitations to actually achieve plan. The decision agility is limited by laborious and tedious manual processes such as feed analysis or lack of visibility or both, typically spread across many departments in a refinery, as some of you may appreciate. And then often due to these different departments, often you see some manual execution because information is contained in silos and not necessarily integrated across the entire value chain. So that kind of sets the premises for production optimization. Now, helping our customers implement production optimization is what we're good at. It's what we're proud of. It's what we do every day. And here I've listed some of our examples where we successfully delivered value. And I truly believe we can do this. We can do exactly the same to your organization. For example, we implemented our PIMS, Advanced Optimization Platform, at the Global Energy and Chemicals Company to more than 15 sites. At Rompetrol, we had cumulative benefits of more than 45 million US dollars over a period of 5 years by implementing our advanced process control technology. So, so that having said that, I believe that there's a gigantic opportunity still to deliver value when you look at production optimization in an integrated fashion. Let's go to the next slide. So this is our what we call our digital reference architecture, and it's kind of a holistic approach to asset optimization. For example, on the left, you see performance engineering, which kind of consists of design and plant digital twins. On the right, you see asset performance management, reliability, prescriptive maintenance. And basically, the left side tells you what your plant can produce, and the right hand would tell you what the condition is of the plant. And then in the middle is the production optimization stack, which goes from planning and scheduling, optimize feeds, processing of products, product qualities, maximize quality and performance, in control and optimize, and finally monitor and execute to make sure that I hear some background noise. Hopefully it's not me. It's gone now. And automate the execution of the plan, right? And then basically our solutions also have a dimension across the production optimization stack, which is the value chain. So forecasting and planning, balancing supply and demand, as well as on the product side, the distribution, and leveraging the new AI infrastructure that AspenTech provides. We believe we can drive new levels of collaboration, but specifically insights and automation across all these functions by providing industrial AI infrastructure to all our applications, so we can help our customers achieve a higher level of asset optimization and ultimately unlock the smart enterprise. But for today, I'm going to focus on the production optimization bit. And the production optimization is really the fundamental building blocks for a future smart enterprise or self-optimizing plant vision. So if we look at the production optimization solution that helps to address margin leakage all across your supply chain by connecting all of these business processes into an integrated workflow, as you can see here. So our production optimization is a unique solution that provides a holistic integrated solution that unifies all these different functions. So when we look at the different layers, the first one is the digital twin. Is your planning model up to date? Do we have the latest representations in our LP? Do we have a tool available that can use machine learning and smart algorithms to provide timely failure alerts? And that could feed into the planning and scheduling layer, where we do planning and scheduling, right? Feedstock purchasing and scheduling. We adjust the operation based on day-to-day disruptions, which could be maintenance related, it could be feed logistics or product downstream delays that could cause the plan to not be achievable, and the schedulers then have to re-optimize the plant, and that's why we see planning and scheduling hand in hand throughout the operating life cycle of a manufacturing plant. Now, AspenTech has unified these functions. If you go to the next layer after planning and scheduling, we go to control and optimize, and really we're getting into operations. And many of you on the call are very familiar with advanced process control. But one advanced process controller on the crude unit, for example, may not be integrated with the advanced process controller that is installed and running on the FCC. So in order to address this, we have developed something called dynamic optimization, which looks at a wide envelope of solutions and connects different APC controllers to achieve its optimum. And this is our GDOT solution, and I'll go a little bit more in detail in the subsequent slides. And across all this is the enterprise visualization and workflow. And then finally, monitor and execute. Are we actually making plan? Where does the data reside? How does it feed into yield accounting? And does it feed back into our different manufacturing work processes? And as you can see, this brings us to the spanning all of this is the overall production optimization solution from AspenTech, and it covers all the work processes in your plant, but in a unified and integrated fashion. GDOT, dynamic optimization, is what I want to talk about a little bit more in detail today, and it basically optimizes across different envelopes in your refinery. It does that in real time. It does it dynamically, and it's integrated with planning and scheduling steers to ensure the best possible economic outcome. Okay, so why is margin leakage so important? We saw in the previous integrated diagram that if one of these functions is suboptimal, there is margin leakage, and this slide illustrates that very nicely. This is based on our internal experience with many clients globally, and it's indicative. What you can see, for example, if somebody would not have an integrated or planning solution in place, that the margin leakage could go up to 50 cents a barrel, and the synergy between all these different functions, we believe, drive very high values and go into the tens of millions of dollars per annum, depending on your complexity and depending on the throughput of your plant. Okay. And I think this is a very very compelling reason to minimize margin leakage. And this slide, our GDOT solution, and it's basically a platform that is used to solve a variety of coordination, but also optimization problems in refining and olefins. So the GDOT models itself, they're derived from our planning models. So, for example, FCCs, hydrocracker reformers. And so the reactor models in GDOT are similar to refinery LP models, albeit that we actually include non-linearity there where we feel that is beneficial, such as a conversion unit, an FCC, or a hydrotreater for that matter. And so they are more detailed models than you would typically find in an LP model. And for this reason, GDOT actually incorporates best of both worlds. On one hand, it's similar to LPs, but on the other hand, we incorporate more detailed and complex models to accurately represent the units. And as you can see here in the scheme, it's a closed loop optimization. So we start with planning and scheduling, and the steers, the ranges of cut points, scheduling constraints, don't make more than this amount of product or stay within these product specifications, are fed into the GDOT applications. The GDOT contains a full refinery semi-rigorous model, as I explained earlier, and then it will connect to all the different APCs, read its dynamic current state and its current limitations, and then optimizes based on all that information coming from planning and scheduling, as well as from the actual operations, the optimum plant operation, and then steers the different APC, coordinates the different APC applications across the different units to minimize the margin leakage. So yeah, it is capable of doing very large scopes of optimization, unlike some of the other solutions that have been out there for a while. Because it's very robust, it solves on a minute-by-minute basis. The solution is very robust against changes. It typically always solves. And we see that in all our existing applications globally, more than 20 at the moment. 90% of our installed base is in the refinery world, that we are solving these real-time optimization problems across different production envelopes. Examples of these envelopes are, you can probably guess it. For example, we could focus on the middle distillates. So the crude unit probably plays a role, the hydrotreaters, the hydrocracker, blenders, a vacuum unit if you have one. Other envelopes that we have successfully deployed GDOT is, for example, the naphtha envelope and also fuel oil. So as we continue to expand the scope of these applications, targeting more and more complex plants to cover larger sections, you can imagine that eventually these envelopes can be connected to each other to cover really a large part of the supply chain of a refinery or olefins complex. One final comment is that GDOT also can provide valuable information to planning and scheduling, because it's integrated. So maybe in the real optimization, we see that the limitations are slightly different from what we planned for. And so there could be a feedback loop into planning and scheduling. And I think this is really exciting that we now see a more production optimization integrated stack from planning, scheduling, all the way down to advanced process control. Right. So here you see an illustration of our gate-to-gate scope of optimization, and as you can see, here's a middle distillate envelope. Our solution actually is a flow sheet driven interface with a standard database for different process units, and so setting up these models will allow consistency with planning and scheduling as they are in the same application. These pre-configured templates also simplify the maintenance of the user and allows the users to focus on analyzing the results rather than focus on complex model integration. Okay, so what are some of the key success stories? So distillate processing, we've shown to increase overall diesel production by 10% at certain clients, and also reduce the average quality giveaway, and this was worth $4 million to $10 million per annum. We also saw successful application of GDOT in naphtha processing, increasing the aromatics yield, for example, by 5% and reducing gasoline quality giveaway. And we've also successfully increased conversion on feed by 3% in a residue processing application. Also interesting is the application of GDOT in hydrogen and utility systems. And they're a bit of a different category, and we've achieved significant improvement there, focusing not really on making more hydrogen, but it's basically to reduce losses and coordinate the different consumers, right, in the system. And then finally, we do have references in olefins where we increase throughput by 2 to 5% by improving the yield. And this is worth $6 to $10 per metric ton of ethylene production. So many global companies have already implemented GDOT. You can see here some of the logos is a sample of customers that actually have presented at public seminars and public events. Okay. As you can see, yeah, GDOT has quite a wide range of useful applications. So here's a case study. The refinery here was the Pembroke refinery, Chevron refinery in the UK, and they wanted to go beyond the individual APCs and improve the profitability of the refinery. So we have applied GDOT there, and it optimizes entire production trains from middle distillates to kerosene and even naphtha by coordinating multiple process units, all closed loop, with optimization cycles of around 1 minute. And actually, we achieved 10% increase in diesel production, which in that year was worth $10 million per annum increase in margins. And a quote from the refinery is that the GDOT system allows operating instructions and strategies to be consistently implemented. So minute by minute, day and night, in the weekend, all driving towards a more profitable and consistent operation, and reducing the margin leakage. So that this continuous coordination is really the key to success in production optimization. Okay. Finally, if you remember, I presented the digital architecture earlier, and another key dimension is asset performance management. Fortunately, today I only have 10 minutes, so very quick. Actually, with our asset performance management, we can expose the condition of the equipment or process by making prescriptive maintenance information available to the planning department. So this enables you to plan interventions ahead of time to either reduce the maintenance cost or to improve the margin leakage that could be caused by an unscheduled event, because you can plan for it well in advance. An example of that was at Saras. They wanted a reliable operation of their refinery with their integrated power plant, and their strategic objective was to improve uptime but also decrease maintenance costs. And we, Aspen, installed or deployed MTEL as part of this endeavor in just a couple of weeks, and we built failure detection agents across a whole set of critical equipment. And as a result, that of that deployment of our MTEL solution that uses artificial intelligence and machine learning to predict failures. We had a 91% detection accuracy with at least 30 days of lead times before a piece of equipment failed. So at the refinery, one statement was that they positively improved the reliability by in 91% of the cases, and this led to a reduction in maintenance costs, as well as avoiding emergency or so-called unplanned shutdowns, and they could actually re-optimize their operation. Okay, so very brief overview. And so our mission at AspenTech really is to accelerate the digital transformation of all the industries that we serve, to make sure we can optimize the assets, to be safer, no unscheduled breakdowns, greener, longer, and faster. And with that, thank you very much. Can everyone hear me?
Hello, Tommy.
Mr. Pramanik, this was the
Hello.
end of my... Hi, can you hear me? Can you hear me?
Tommy, I think Mr. Pramanik is having a problem
Tommy, have
in
you finished with the
hearing you.
presentation?
Mr. Pramanik, if you can hear me, Tommy has finished his presentation.
Could you hear me okay?
Hello.
I'm now getting worried. Was my audio coming through?
Thank you, Tommy, for the presentation. Can we take up the second speaker?
Yeah.
Alicia, can we take up the second speaker now?
Yes, I would like to just tell Tommy that we were able to hear his entire presentation and see his presentation also. Thank you for your presentation.
Thank you. I was getting a little bit worried there. All right. Thank you very much. Over to Mr. Pramanik. Thank you.
Hello, Alicia.
Yes, Mr. Pramanik, please go ahead, sir. You can introduce the next speaker, sir.
Can we take up the second speaker now?
Yes, sir. Yes.
Yes. Now I request Saurabh Tayal of ActionShare to start with his presentation. He has 18 years of experience in the oil and gas sector. And now I welcome him to make his presentation. Saurabh, we have 15 minutes plus 2 minutes of grace time. Thank you. Please go on.
Thank you, Mr. Pramanik. Anisha, Sunny, if you can put up my presentation.
Yes, I will request the team to do that. Just give us a minute, they'll play the presentation.
Meanwhile, I'll just do a quick introduction. So thank you, everyone, fellow panelists. I have in total about 18 years of work experience, work largely in the oil and gas sector. Currently, I am a senior principal and client account lead at X. I work extensively in the digital and analytics space, in both upstream as well as downstream. In the resources practice at Accenture. Prior to this, actually, this is my second stint with Accenture. I worked with Accenture back in 2006 to 2010. Then I worked with BCG for a while, worked with Monitor Consulting for a while. Now I'm back with Accenture. I'll just wait for the presentation to load and then I'll probably start. Perfect. So if you can go to the next slide, please. Great. So I guess let me just start by stating the obvious. We are living in unprecedented time. Oil industry is no stranger to disruptions. In fact, I believe oil and gas industry is just working from one disruption to the next. By the time we manage to contain the effects of first disruption, the second one comes over. But especially these times are truly unprecedented. On one hand, there is worldwide oversupply. On the other hand, there is acute demand compression caused by COVID. And add to that, energy transition, climate change, high level of debt, vulnerable supply chains brought about by COVID, decarbonization. Uh, I believe oil and gas industry is facing many colliding storms simultaneously, right? Uh, Crude oil price is where it is. There has been umpteen number of projections on crude oil price, but none of them are talking of high crude oil price in the upcoming future. No one is talking of $100 plus scenario again coming in this world. So if low crude price is here to stay, the current cost structure that refineries have may not be sustainable. Refineries have gone through different levels of cost reductions in the past, and I believe more is needed. Oil and gas industry is looking for a navigational aid which will, so to say, ride them through these turbulent times. And this is what at Accenture we call as digital compass. The four cardinal directions of the digital compass being, journey to cloud. I believe we all have an understanding of journey to cloud. It's become even more important in the current times. Second is something we called as dark power. That's DARQ. I'll speak about it more, in a few minutes. Third is transitioning to become an intelligent enterprise. This is essentially using all kinds of digital and analytical models to take decisions. Sorry, am I audible? Was there a question? No, I'll just continue. So third being the dark power, and fourth and last one being cybersecurity, right? People say that data is the new oil. The energy industry is up to its neck, in petabytes of data, but uses less than 5% of it for decision making. The vast amount of that unused data is currently represents several hundred billion dollars of trapped value. I think that is what this digital compass is trying to unlock through the various things that I'll talk about now. Let's just start with, if you go to the next slide, the first of the four, which is journey to cloud. Essentially, cloud is a paradigm shift in computing, offering companies seamless and flexible access to virtually infinite computational power. With cloud, companies can employ applied intelligence and respond to their business and market needs at speed and at scale. So what it does is basically transforms the industry in two steps. First is you start with moving your data, your applications, and even all your analytics to cloud. So it breaks the traditional silos that the industry has been witnessing. From a current state of where some parts of the organization have more access to computing than other parts of the organizations which have very little access. It changes the scenario to a uniform access to much better data as well as computing power, right? Second, what it does is it supercharges the new integrated enterprise with differentiating capabilities such as artificial intelligence and machine learning. It opens the doors for unconstrained innovation. So cloud has become a must-have capability, and there are multiple discussions we also as Accenture are having with clients in both upstream as well as downstream space as far as cloud is concerned. And when we talk of cloud, and actually this is relevant for everything that I'm going to speak about, incremental improvement around the edges is no longer enough. I think that's That's a mantra that we have to, that goes through the entire presentation. We need a complete reinvention, something where you can see multiple returns on return on capital employed, essentially, right? If you move to the next slide, the second one we're talking about is essentially the dark power. Here, D stands for distributed ledger or blockchain technology. A is artificial intelligence. R is extended reality. And fourth, the Q is essentially quantum computing. We at Accenture call this quartet of technologies dark. In an Accenture survey, 85% of energy executives confirmed that their organization is experimenting with one or more dark technologies. While each dark technology is powerful in itself individually, collectively they'll change how the industry looks and works. Imagine a scenario, where a downstream company wants to, let's say, expand its petrol pump network or fuel retail network. It can use machine learning algorithms on its current petrol pump network data, uh, add other sources of data such as highway data from NHAI, Government of India, competitors' pumps network, their volumes, historical traffic information, the new road network that is being established. It can take all of that into account, and AI can then suggest locations for setting up new petrol pumps, optimizing for different business objectives. Uh, Extending the same theory, same example, the downstream company can then create a consortium to engage services of multiple tanker providers to keep these new petrol pumps supplied. These transactions can be executed via distributed ledger technology, that is blockchain, and allows for auto governance of smart contracts. Right. The petrol pump attendants can be supplied with peso compliant smart glasses that automatically detects the vehicle number, scans the engine compartment, and nudges the attendants to cross sell or upsell. Finally, quantum computing can be used to solve for real-time routing of tankers, to geographically diverse petrol pumps, or even to consumer homes for doorstep delivery of fuel. We know, doorstep delivery of fuel has been coming up in the recent past now. So the quantum computing can help calculate the shortest route to each of the target locations, given a known set of constraints such as appointment time windows, location, capacity of the tanker, time or distance to the location, etc. So that's basically the power of dark, that we are referring to. If we move to the next slide, the third cardinal direction that I spoke about is transforming into an intelligent enterprise. Most organizations today, take decisions basis the feelings and instincts of experienced executives based on their experience, with the hope that the impact will be positive. But there is little control over all the facts to ensure a good outcome. So I'll take another example here. So imagine, that a company receives news that there is a distressed cargo available at a discount. If that company applies traditional linear programming models to optimize refinery operations, it will be unable to assess the implications of buying this cargo from an integrated margin perspective. An intelligent enterprise will deploy new operating models that take risk, cost value trade-offs, incentives, governance structures, technology, data, etc. into consideration. Such an enterprise will be able to apply advanced analytics to optimize all aspects of refinery operations, from crude procurement to demand management, across a portfolio of lubricants and petrochemicals. These advanced analytics can help reduce the time it takes to make these kind of decisions. So I'd like to point out here that our digital downstream value chain is not infallible. There may be times where, and especially early on into the digital journey, where you see that the output of a digital value chain or a digital model is worse than what an experienced executive might decide. But this is not a sign of model being flawed and that it should be abandoned. Rather, it's a sign that model is gaining insight and knowledge and will continue to grow in effectiveness. In the same way as downstream experts have learned by doing, models will too, but they'll learn much faster and much from a much broader perspective with much more data capabilities. All right. The fourth one of the cardinal direction is essentially cybersecurity. If you see traditionally, OT, as we call it, operational technologies, was not connected to the internet. But with convergence of IT and OT, energy company assets are increasingly getting connected and thus vulnerable to OT attacks. Industrial control system platforms that are central part of OT network, along with IT network, form the industrial Internet of Things. As more and more devices get connected to IIoT, highly sophisticated cybersecurity threats enter the OT environment. They pose hazardous risk, to our critical infrastructure, such as refinery units, production lines, plant, and in the upstream context, oil rigs. These are all national assets, and I believe there are regulations which are hindering movement of IT/OT integration precisely because of these risks. However, I think one needs to look at these regulations from the lens of how much the cybersecurity technology has advanced now, and making some of these possible in a risk-free manner. What energy companies here can do is stress test their IIoT platforms in industrial control system cyber ranges. These cyber ranges can help in a risk-free environment, simulate the responses of industrial process controls against sophisticated attacks. Additionally, these cyber ranges can help energy companies conduct threat responses to train their teams to more effectively recognize, mitigate, and repel attacks. So those are the four kind of cardinal directions that our digital compass kind of has. I'm not talking about specific use cases. If we talk of, for example, downstream refineries, we have enough number of proven use cases in process analytics and machine analytics. I'll extend that to even lubricants, where there are applications around developing a platform. So there is adopting a platform strategy or digitizing the existing front end and back end operations. Similarly, it is true for even fuel retail and marketing. Uh, what I want to, in my last slide, if you move to the next, what I want to summarize with is, three aspects essentially. One is there has been a lot of progress as far as digital implementation is concerned in the downstream sector. However, what we currently have as proven models is simply scratching the surface. There is a lot more that needs to be identified and invented as far as use cases are concerned. So as this technology takes its journey and becomes more mature, we'll uncover more and more. But there is enough to go on to start with, which will give confidence to the executives to take the plunge. So that's point one. Point number two is digital journey is as much a organizational and cultural transformation journey as it can get. Uh, Trusting digital model beyond your own gut and instinct, it will take time, and companies will have to really focus on organizational change management, executive sponsorship, etc., for some of these initiatives to really succeed. And finally, I believe the successful companies of the future are going to be the ones who can work with the ecosystem of partners in a seamless manner. Gone are the days where it's even more important, because you don't know how the capabilities are changing. That there's a lot of dynamism in the environment, so you don't know what technologies you need to own and learn, what technologies you should outsource. So working with ecosystem of partners becomes even more critical than before. Yeah, so that's what I had. Thank you so much.
Nice presentation. Now I request the third speaker, Kunal Dixit of DuPont Sustainable Solutions. His topic is mindset and culture for adapting to the new reality. So now I request Kunal, who is an electronics and communication engineer and an MBA. He has more than 18 years experience in leading digital initiatives in the oil and gas sector. Now I request him to start his presentation. Thank you. Over to you, Kunal.
I hope I'm audible. Can you confirm that, sir?
Yeah, you are audible to me. I hope
Oh,
the audience also you are audible.
thank you, sir. So, uh, under the theme of Downstream 4.0, smart manufacturing and digital transformation, I'm here to today present DuPont Sustainable Solutions point of view on mindset and cultures for adapting in the new reality. At DuPont, we always start our meeting with sharing a core value which we live. In this case, I want to, uh, you know, bring about a thought process in terms of whether we really understand the infrastructure and facilities risks in the downstream 4.0 scenario, right? Just an year back, there was a drone attack at two Saudi Arabia refineries and a massive fire broke out. Are we really prepared in terms of regulatory measures to, that to counter such threats? As well as, do we have risk mitigation measures that have been deployed at our refineries in India to make sure that we do not are exposed or get threatened by such risks? With this thought, I'll move on to the presentation. The presentation is divided into three parts. The first part is downstream 4.0, and we'll focus on the seismic shift that's happening because of that, the technologies which are coming in. Then I like to share our perspective on mindset and culture and the challenges that are coming for digital transformation. Then I like to, showcase our approach for addressing these challenges which are there through an example of digital assessment for a refinery. Are we ready for the inflection point in the world? Number of devices connected are going up, and at this juncture of time, it is just the beginning of the exponential curve. Similarly, for data proliferation, it has started to go up, and it is at an inflection point of the exponential curve, which will go up from here. The computing power has been growing exponential for a few years. And this seismic shift, what is it doing? For companies, it is making difficult to adapt to the new reality. Even and the tenure of Fortune 500 companies has been coming down because of disruption caused by these technologies. Now, there are essentially 10 technologies which are there in today's scenario in Industry 4.0, causing this seismic shift. What these technologies are, to a large extent, is understood by the management of the companies. But what about the front line? Do they really understand the implications of these technologies that they bring in? Have they the required skills and capabilities? Has the organization developed their skills and capabilities to an extent so that they are able to adapt and survive in the new environment? Now, where these technologies can be deployed in the organization, be it R&D, manufacturing and logistics, sales and distribution, is understood to a certain extent at varying maturity levels across the functions in the organizations. But will a piecemeal approach work, for one function or for one domain to do a small pilot in this? Will it really help organizations survive to adapt in the new environment? And then the why and how part understood even by the management. What are the implications of not transforming, of not adapting to the completely new ways, take bold step and transform the organization, and how to do it in terms of process technology, and more importantly, people, how to develop a culture of change which is accelerating. A lot of leaders are having a thought around culture and making it one of the key aspects of the transformation that is coming in. Because culture transformation is an implicit part and often the part which makes the success and the success a reality. Without cultural transformation, success can never be achieved. At DuPont Sustainable Solution, we leverage the DuPont experience to derive insights on mindset and culture transformation. At DuPont, we have experienced 4 industrial revolutions, starting with the mechanical production and to date with the new technologies that are coming in. And so we derive our best practices, learnings, and methodologies, from what we have seen during this course of time and what we have learned and implemented. In our perspective, there are three critical challenges for companies to overcome to achieve the full potential of Industry 4.0 digital transformation. First is a vision and mindset around digital maturity. A lack of digital transformation strategy or roadmap. Is it understood across the organization? Do they have a vision of how to redefine doing the new things, making, with technologies as enablers? Second is the scale in terms of value chain. Do they have the will to, transform across value chain, across functions, and across levels? And do all people in the organization across all levels have the mindset aligned, have the competencies built in for the change objective for sustenance? Do they understand that the new structures will need to be redefined and there will be new ways of work to get done utilizing these technologies? Thirdly, the challenge is that people expect technology to solve problems. The technology doesn't solve problems, it is a business transformation which can be enabled using these technologies. So these are the three challenges. Now I would like to showcase an example on how to address these challenges to start building a roadmap for the transformation by doing a digital assessment. I'm taking a case of a digital transformation roadmap for a refinery. It begins with business at heart and people at the center. So first and foremost, across the value chain, we define the critical functions that are there. In this case, we have taken 4 functions that are there, and then we have bucketed more than 50 domains which are there in the organization or in the refinery under, bucketed under the functions, the 50 plus domains. So for example, if we take maintenance and reliability, we have bucketed 5 domains of turnaround, equipment performance, so on and so forth under it. Why is it important? Because we need to understand what digital interventions are required in each of these domains. What competencies and mindsets do the frontline personnels are having in each of these domains? Because they generally are at different varying maturity level in the organization. What needs to be planned to bring them to a level, and what kind of implementation can be done? The approach that we adopt is in terms of process maturity and digital maturity, with the people aspect inbuilt in both process as well as digital. So for example, if we see for a low process and low digital maturity, in an organization where the processes are not really matured, we need to enhance the process, find the gaps in the process, enhance them, and enhance the systems. Accordingly, the competency of the people also needs to be enhanced to that level to make it a success. Going on to the lower second dimension, which is high process maturity, where there is in these domains, but low digital maturity, we need to upgrade the systems and let people know what upgradations are required and how the systems will function. Similarly, on the low process maturity and high digital maturity, we try to do a system integration, a dashboard connectivity, so that people can understand how things are integrated and enable the functioning of the processes accordingly with the digital maturity available. The final quadrant of high digital maturity and high process maturity requires significant efforts in terms of competency building and deployment of technologies, be it advanced analytics, machine learning, Internet of Things, artificial intelligence. And after doing this whole piece, assessing each domain onto this methodology, we also do a business criticality of each of these domains in terms how critical is that from a business standpoint so as to prioritize the investment in implementation. Coming back to our example on the left hand side of 14 functions in which the 50 plus domains were divided, we do a complete digital maturity assessment. We have taken the example of one of the functions, which is maintenance and reliability. Under this function, on the right hand side, you can see 5 domains of maintenance, reliability, turnaround, instrumentation, and equipment. We do an assessment including people as a part of both process maturity and digital maturity, and then talking with people, getting their views, and understanding from a business standpoint, we give a business criticality score to each of these. And then we define the interventions that are required in each of these domains under a particular function, going across for all functions and then enterprise wide across the value chain. To just showcase an example of how the digital interventions are done and plotted. So for example, in the maintenance and reliability function, which we have been taking, total 15 number of challenges were identified along with the people in that particular function. Then 7 digital interventions
Hello, Kunal.
were hello.
Yeah, this is your chairman speaking, session chairman speaking. Could you please wind up in another 2 minutes? Because we are.
Sure, I'll go a bit fast.
Yeah, please, please. Thank you.
Thank you, sir. So then we kind of, placed around 7 digital interventions, 6 of which had a high impact in organization and 1 had a medium impact, be it turnaround time, process reports, so on and so forth. Then we kind of did a projects around each of these implementations. The duration, everything is being mapped out in this particular chart. What it takes, the digital interventions take a little time, but the organization capability and the transformation from a culture specific point of view takes a longer time. And this is where we kind of help our clients in hand holding, making people understand the technology implications and bringing turnarounds. Similarly, from a digital assessment perspective, since we have taken the case of maintenance and reliability, the suggestions for IoT came up, integrating them with the asset management software so that the maintenance in charge can get an equipment health in the real time through KPIs in terms of demonstrated health meters, correlate cost of failures, predictive failures, and the frontline maintenance personnels can automatically get generated schedules and alerts so to take action. We did it across all 14 functions and then gave a business criticality score in terms of prioritizing the investments, and then developed a roadmap taking into account and addressing the 3 challenges of one, the complete vision, the scalability part through across all levels in organization, across functions and across the value chain, and third, which is basically building a competency roadmap for the people to achieve that. With that, I'd like to end my presentation in the interest of time. Thank you so very much. For a detailed conversation, I'm available. My email address and phone number are given there. I'm representing DuPont Sustainable Solutions. We do, consulting in the areas of safety risk management, operation excellence, learning and development, digital and innovation. We have been recognized by a number of awards across globe, and we are one of the leading consulting agencies, consulting companies in the field of asset management. Thank you so much.
Kunal. So we had a lot to learn from your presentation. So with that, this technical session on digital transformation comes to end. Before I hand over to the organizers, I'll just summarize what we learned from these three wonderful presentations given by Tommy Kurtz, Saurabh Tyal, and lastly Kunal Dixit. What we learned is, one is the production optimization is the need of the hour. Then culture transformations are necessary both amongst the organization and the people manning the different verticals in the organization. Then we learned about some refinery case studies where these software were applied and the solutions given by Dow and Aspen and Accenture was highlighted. So in all, it was a very enlightening presentation, and hope the delegates and the attendees learned a lot from these presentations. Thank you very much. And Q&A, Alicia, will we have a Q&A?
Sir, if there are questions, you can take a couple of them.
Yeah, but it's not visible to me.
Right.
Can you,
Sir,
can you ask,
sir, I've
can you
had a
read
look
out
at. Sir, there is one question that is coming from Pradeep Sahu. The benefit of low crude oil is still far away from gasoline consumers. What could be the strategy so that common people can benefit from low crude price?
So, Tommy, can you enlighten us on that question? Hello.
Hi, yeah, Tommy here.
Yeah.
Yeah,
There's
so
one.
yeah, can I ask to have the question repeated, please? I heard the first bit, but not the last bit.
Right. Mr. Pramanik, we are not getting questions specific to the speakers, and these are more general questions, and they're largely observations which have come in.
Okay.
So I think there aren't any real questions to go to.
Okay. So can we then wind up the session?
Yes, sir. I would request you to please wind it up.
Yeah, I'd like to wind up the session after all the three speakers. Thank you very much, and thank you for the patient listening. Thank you. But over to Alicia.
Thank you so much, sir, for taking us through this insightful discussion on how new technologies are transforming downstream oil and gas industry. Of course, we heard our speaker say that there's a lot of data, but a lot more can be done. And as and when there'll be more adoption of newer technologies, we'll see new changes come about. Thank you so much for joining us. Now we will have our next technical session. Before we start with our next technical session on next generation catalyst, we'll take a short break. We'll connect with all our speakers and we'll be back in a jiffy. Stay with us. Right. I think all our speakers are here.
Yes, ma'am.
Hello, good afternoon, everyone.
Good afternoon, everyone. Hi.
Okay, great. Mr. Kumar, if you're ready, shall we start with this? I'll just give a quick introduction to the session, which is, of course, on next generation catalysts. Catalysts play an increasingly critical role in modern petroleum refining and basic petrochemical industries that, as market demands for and specifications of petroleum and petrochemical products are continuously changing. Refining is always looking to convert valuable products. So what are the new type of catalysts that are being developed so that the cost can be brought down but performance remains high? And given the changing price dynamics, what one will emerge as the most popular? To talk about these, please welcome our eminent panelist who will be discussing some of the next generation catalysts. We have thus Mr. Arvind Kumar, Executive Director, Mathura Refinery of the Indian Oil Corporation, who is the session's chairperson. Please also welcome Gary Cheng, Regional Marketing Manager, Asia Pacific, WR Grace. He will be speaking about next generation FCC catalysts and additives for max propylene operations. We have with us Mr. Ram Babu Raja, Technical Service Manager, Shell Catalyst and Technologies. He'll be speaking about nano-engineered zeolites in hydrocracking catalyst. And we have Dr. Gurmeet Singh, CRM, Petrochemicals and Polymer, IOCL R&D Center. And he has a presentation about innovation-driven polyolefin catalyst development. So welcome to all of you gentlemen, and I'll request Mr. Kumar to please steer this discussion forward.
Yeah, thank you, Anisha. I welcome our distinguished speakers on today's topic of next-gen catalysts. I first introduce myself. I am Arvind Kumar, as Executive Director and Refinery Head of Mathura Refinery, Indian Oil Corporation. Our esteemed speaker in this technical sessions are Mr. Gary Cheng, who is Regional Marketing Manager for FCC Asia Pacific in WR Grace. He is presently located at Singapore and involved in implementing mid and long-term product and services strategies for Asia Pacific region. His topic for today is next generation FCC catalysts and additives for maximizing propylene. And it is an apt topic today as propylene fetches the maximum cracks and GRM in refinery business. Welcome Mr. Gary Cheng to technical session in GRPC. Our second speaker is Mr. Ram Babu Raja, who is Technical Services Manager for Shell Catalyst and Technologies. He provides technical support to the hydroprocessing catalyst business and technology licensing in India. His topic for today is nano-engineered zeolites in hydrocracking catalysts, unlocking ultimate performance, which is very interesting topic. And this will add to the higher conversion, reduce costs, and high margins for refineries. Welcome, Mr. Ram Babu Raja, to this technical session in GRPC. Our third speaker is Dr. Gurmeet Singh, who is Chief Research Manager and R&D Center of Indian Oil Corporation. He is actively involved in developing and research in polyolefin catalyst systems and production processes, specialty chemicals and products, lubricants, process intensification, circular economy, and molecular modeling. His topic for today is innovation-driven polyolefin catalyst development. This is a very interesting research topic. Polypropylene and petrochemical business promises good return and margins to today's scenario. Welcome Dr. Gurmeet Singh to this technical session in GRPC. Now to the esteemed speakers, I propose the timeline, and every speaker may be allotted around 15 minutes each. And please honor the timeline to finish your topic. And further propose that question can be asked by audience in chat box, and those will be answered by respective speaker at the end of the all presentations. I mean all the three presentations, so that the flow of the presentation in virtual mode is not disturbed. So let us begin with our first speaker, Mr. Gary Cheng of WR Grace. Hand over to Gary. You may proceed.
Okay, great. Thank you very much. Can everyone hear me and see my screen? I'm sharing the presentation currently. Hello, am I audible?
Yeah, Gary, you can go ahead.
Okay, excellent. Well, first I wanted to start by thanking GRPC, the event organizers, and for allowing myself to have the opportunity to present to all of you today on behalf of WR Grace. And thanks to all of you for your time in joining us for this technical session. So for this one, we'll be talking about next generation FCC catalysts and additives for max propylene operations. Okay, starting off with first a little bit of background about Grace. So Grace is a global leader within two major business segments, catalyst technologies and materials technologies. We're a customer-focused organization with a long history in catalytic technologies. We have about 4,000 employees in over 30 countries, with our headquarters centered in Maryland and the United States. And as shown on this slide, we are an industry leader in several technology areas, including FCC catalysts, hydroprocessing, and the other areas that is listed there. So as mentioned throughout the wonderful sessions today, transportation fuel demand growth is expected to slow down in the coming years, whereas petrochemical feedstock demand growth is positive across the globe. In India specifically, the trends are positive for petrochemical feedstock demand growth, and Grace has demonstrated excellence in helping our customers maximize propylene. Here are a few successes that we've had in India, including the supply of catalysts and additives to some of the leading refining organizations across the country. Our successes include about 10 years of supply of ZSM-5 additive to the largest FCCs in India and in the world, Reliance. Supply of catalysts to deep catalytic cracking units, DCC units, such as MRPL. And further, we've supplied the YZLA catalyst to the first production scale INMAX unit. And as the first production unit of this new made in India technology, performance of our catalyst was critical to meeting all the guarantees. These successes demonstrate that Grace stands ready to help our customers achieve their most challenging max propylene goals. All right, as far as the theme of the technical session, we like to provide a preview of some of the next generation FCC catalyst and additive technologies that Grace can provide. We're very excited to share some very recent commercial performance data from some of our latest step-out technologies. These include both catalyst and additive platforms. But first, taking a step back into the technical details behind all of this. So generating propylene is a multi-step process involving both YZLA matrix as well as ZSM-5 additive. So starting from the left side of this graphic, we have our feedstock going into the FCC, which can be arranged anywhere from vacuum gas oil to heavy resids. And the YZLA matrix catalyst convert the feedstock into valuable liquid products, such as LCO, naphtha, LPG, and some unwanted products as well. And the purpose of this is really to drive some conversion into the precursors for the ZSM-5 zeolite, which will ultimately convert the liquids into valuable propylene. So throughout this presentation, we're going to dive deeper into both catalyst technologies as well as additive technologies. And the catalyst that I mentioned here is RIVE technology, which was alluded to earlier today in the panel discussions by my colleague, Mr. Vipin Goel. And the ZSM-5 additive technology is Avanti. This is really a step-out technology. We're very excited about it, and this will be actually one of the first public forums where we've shared some very recent commercial data of this next generation additive. So hopefully throughout this presentation, you'll get the sense that Grace continues to make advances in catalysts and additives for max propylene applications to coincide with the growth of the market. So again, building on some of the opening remarks and comments from the inaugural session this morning, catalysts are a key contributor in maximizing profitability of refinery operations. First, I wanted to provide a little background about Grace and RIVE technology. So RIVE was an invention from MIT, that's Massachusetts Institute of Technology in the United States. And they invented this technology and sought a partnership with a major FCC supplier, and they chose Grace. And since 2010, Grace and RIVE have worked together to combine molecular highway YZLite technology with Grace's market-leading position and experience in FCC catalysts. Together, we co-developed and marketed RIVE technology with the first application in 2013. And through the years, Grace and RIVE both were very encouraged by the widespread commercial success that we were noticing globally. And in June of 2019, Grace Refining Technologies acquired RIVE and RIVE's patents and assets and brought them effectively under the Grace umbrella. So let's dig a little deeper into RIVE technology. So what is it? So RIVE offers a unique modification to the zeolite that's contained within FCC catalysts. Shown in the graphic to the left is a traditional YZLite technology where you have pores that are optimal for cracking certain type of molecules and certain size molecules. What RIVE offers is a unique patented process that creates a network of larger 40 angstrom pores throughout the zeolite crystals to enhance diffusion. It allows larger feed molecules to enter and also exit so that you can effectively convert the feed into the products that you desire and you avoid overcracking into undesirable products as a result. So overall, it enhances the diffusion properties of the catalyst, and the net effect is it introduces industry-leading coke selectivity. And I encourage you, if you haven't already, to visit our virtual booth. We have a very neat video that goes into more detail about RIVE technology and the unique features that it offers. So this slide includes a table that shows some of the widespread worldwide success that we've had with Rive technology, proven value delivered across the globe, all North America, Europe, and Asia Pacific region. You can see that there is a range of different unit types, different feedstocks, as well as metal contaminants for the ECAD in the unit. And in all of these examples, the value delivered was substantial, right? It was delivered through improvements in coke selectivity, liquid product yield, and overall olefinicity coming out from the FCC. One key item is the last column here is the incumbent supplier prior to the use of Rive technology. We've got examples over competitor A, competitor B, and also over our own traditional technologies where Rive has offered substantial yield improvements and enhanced profitability for that particular refiner. We have a few publications that we presented in previous conferences and technical journals. Again, these are downloadable at the virtual booth, and I encourage you to stop by. As mentioned earlier, back in mid-2019, Grace brought Rive under the Grace umbrella, which allowed us to really push the envelope and continue exploring and innovating with what this breakthrough zeolite technology can offer. Shown in the plots to the left are Rive technology in blue, and some of the next generation Rive that our R&D group is actively experimenting with in purple, right? So we're continuing to push the envelope on conversion, on coke selective slurry upgrading, and really driving more profitability by using this technology. Shown on the top right is some Rive technology extensions, including how to apply Rive in concert with ZSM5 to drive optimal propylene yield for refiners. And finally, we're also innovating in the area of chemicals, where Rive has the ability to improve transalkylation chemistry, as shown in this graphic on the bottom right. So now a very recent case study. So as I mentioned earlier, we're very excited to share a few recent examples of how our catalysts and additives have delivered value in the marketplace. So this one is in an EMEA refinery. This was the first Rive trial in EMEA, and their value creation wish list is shown there. They wanted to decrease slurry yield, maximize heavy feed processing, and increase other liquid yields as well, including gasoline and diesel, all while maintaining or reducing catalyst addition rate. Shown in this table is the feed properties for this particular FCC unit. And these are the deltas that were established with Rive, right? Showing the standard feed conversion over 3% change with Rive over the incumbent competitor catalyst. And then going down the list of other products, you can see an increase in propylene as desired by the refiner, significant improvement in slurry upgrading, and a reduction in coke. This refiner estimates that the value uplift for Rive technology over the competition was in excess of $1.20 per barrel. So significant value delivery, and this refiner continues to use the Rive technology today. So looping back and tying back to the inaugural session and the panel discussions, there was repeated mention of sustainability. This is a key topic in today's world. While Grace is making advancements in sustainability in many facets at our own manufacturing facilities, as well as our products, one key product technology for our customers is Rive, as it offers the lowest coke make per unit of conversion of FCC feed. Rive Catalyst provides refiners the ability to overcome traditional unit constraints, such as wet gas compressor, regenerator bed temperature, etc. Rive offers the ability to have the lowest dry gas make in industry, process unconventional feeds such as bio oils or unconventional streams, and overall offer the best coke selectivity in the industry. So this results ultimately to a decrease in CO2 emissions. And finally, as shown in the bottom bullet point there, minimize logistics footprint at our manufacturing facilities across the world. All right, as mentioned in my earlier slide, while we talked about Rive technology and catalysts, we're also very excited to share some news about a recent trial for Xavanti, which is the latest additive available from Grace. So again, this is the first public forum where we're sharing the story, and I hope you find it interesting. But first, let's have a quick look back on the history of innovation for Grace in the area of ZSM5 technology. So Grace developed the first DSM-5 technology in collaboration with Mobil back in 1984. This was called Additive O. And through the years, you can see a pipeline of new products that were introduced by Grace. Olefins Max, Extra, and Plus throughout the 90s and early 2000s. Olefins Ultra, HZ, MZ, and this latest one is Zavanti, right? We felt that for the long history of olefins names tied to the product, Zavanti was really step out and gives it the credit that it deserves because it really is a breakthrough technology. Shown on this slide is the importance of tailoring the additive to have optimal activity and stability. So in the past approach, by the arrow that I showed on the previous slide, typical approach to increasing the amount of propylene that a ZSM5 can generate is by increasing the zeolite content in the additive itself. What Zavanti offers is an increase in activity of the zeolite itself rather than the amount of zeolite. So you can see the bar charts indicate that Zavanti is really in a class of its own. Relative propylene activity as compared to previous available additives from Grace, including Olefins Ultra MZ, which were already in their own right industry-leading additives. Zavanti is really a step out. The bottom right graph is some data indicating that the activity retention of Zavanti is far superior to the competitor additives that were tested. After a number of deactivation cycles, the relative propylene activity was well retained. So here we go. Here is the trial data that is very recent from a refiner in the Middle East. So we've had for this refiner, they're a large facility integrated with petrochemicals, and they had a high value for propylene as well as ethylene. So what they did was they wanted to replace.
Mr. Gary, as your session chairman, for last 2 minutes to wind up, please.
Sure. Yeah, I will do that. Thank you very much. So for this refiner, there's a high value for both propylene and ethylene. And the objective was to replace the base additive with Zavanti at the same additive percent. This unit operates a very challenging feed, about 4 to 5 weight percent CCR, and the metals are shown there. Pretty high metals in both nickel and vanadium. And the box plot shows the change from the base additive to Zavanti. And a quick review of box plots. I mean, this is a statistical representation of months of data from the trial period, where you can see a significant change in the mean, which is the crosshairs, mean of the data, the median, which is the horizontal line, as well as the distribution of the data. So a significant uplift in propylene, ethylene, butylene, and not shown here is RON. But in all, this refiner quantified a value uplift of about 75 cents per barrel, which equates to about $27 million per year for use of the Zavanti additive. So in summary, I hope you were excited to hear about some of our latest catalyst and additive technologies. Grace continues to innovate. This is our bread and butter. This is what we do. We're dedicated fully to the catalyst space. We've introduced some breakthrough technologies in recent years, including Rive and Zavanti. And as shown in the previous case studies that we've presented here, refiners have really capitalized on these technologies and been able to significantly improve the profitability, especially for max propylene operations. So with that, I thank you all for your attention, and I'll turn it over to our chairman.
Thank you, Gary. Our second speaker is Mr. Ram Babu Raja. The floor is handed over to him for his presentation.
Thank you so much, sir. Let me share my screen. Okay. Can you able to see my screen yet?
No, not now. If it is a delay, Ramabu, can we come later and we can give floor to Dr. Gurmeet Singh?
Sure, sure. It's somehow
You
I'm
can,
not able to.
yeah, no problem. You can contact GRPC and get to know. So, Dr. Gurmeet Singh, can you are you ready to go ahead with your presentation?
Yes, sir, sure.
Yeah.
Good afternoon, sir. I hope the slide is visible.
Yes.
Very good afternoon, and thanks to GRPC for giving this opportunity. The topic of this presentation is innovation-driven polyolefin catalyst development. To just to give the brief that I'm leading the team of scientists at Indian Oil R&D Center who are working in petrochemical and polymer division, and we have got one of the best equipped laboratories in India and one of the best globally also, which is well equipped to handle any type of synthesis, be it organic, organometallic, oligomerization, and polymerization. So, and every work what we do, every project which we drive is always on innovation basis, and that innovation has got a reason to it. As you will see, there is an old man in this slide, and many of us would recognize him as Charles Darwin. And in the famous voyage on HMS Beagle in 1831 to 1836, when he observed the nature very critically, and then he coined that if any species has to flourish, it has to adapt, or either it will perish. And adaptation is now for the current regime is we can resonate it with the innovation. In the current scenario, in the current times, if any organization will not innovate, it is going to perish. And that innovation has to be done at the research and development phase, at for the business strategies, for the business model, everything we have, anything what we do has to have some innovation. We have to do the things differently with respect to what others are doing, else we can't survive. And that is the mantra which we have adopted, and we continue to do the innovation. Now, if we compare India in comparison to the other leading players, this is a data from WIPO, World Intellectual Property Organization. And this data is from 2018. This is the latest data which has been published by WIPO. And the graph has got the number of patents filed in top 10 jurisdictions by the residents and the non-residents. And this gives us a very good indication that how each country is developing its innovation and how the markets are developing. If I consider that, if we see the first country on the graph is the China, and the number of patents being filed by the with the China are equal to the next 10 jurisdictions. This is the one trend which is we should be aware of, and maybe we should get encouragement and increase our patent filing to encourage the innovation culture in any country and every company. Second is this orange bars which are indicating by the patents which are filed by non-residents. And in this, the US is on the top. The reason is that the US is considered to be the best market globally. So all the companies who are innovating tend to file patent in USA so that they can get the innovation secured in a place for which they can find a market to their product. And if we consider India, in India also the things are improving year over year. And again, India is considered to be a very good market, and we can see that the patents filed by non-residents in India is more than the patents filed by the residents in India. And we are, as Indian Oil, we are striving very hard, and we want to see that our country jumps some position towards the left, and maybe from top 6 we then come to the top 3 or 4 countries in short while. And this is our second indicator of innovation, which is the patents filed per unit of GDP, and here the unit of GDP is considered to be the US dollar 100 billions. And over here again, the Republic of Korea is on the top. Uh, they are filing a maximum number of patents per unit of GDP, and we can see that they are now sort of slowing down between 2008 and 2018, while China has taken a leap jump in this respect. Japan, again, because of old and very matured economy, is slowing down. India is not in top 10 countries, and in this graph, top 3 countries are from Asia. We have 6 representations from Europe, and then there is USA. And hope to see India in this graph a few years down the line. Now, keeping it up with the spirit of innovation, we take a lot of pride and we take a lot of inspiration from the Make in India program of Government of India. And the symbol of the Make in India program itself is a very powerful. It is a lion which is imbibes the our enlightened past, and it points the way to a glorious future. Now, it is definitely pointing to a glorious future, but we consider that innovation is going to be the stepping stone if we want to have a glorious future. And for that glorious future, what as Indian chemical industry should do. On this top left-hand side, I have a representation where, though this is a little old, but it still hold that in India, the chemical industry, the split is highest if you consider the split between basic chemicals, specialty chemicals, and the knowledge segment. The major contribution for Indian chemical industry is coming from the basic chemicals, then specialty, then knowledge segment. And we aspire to have the technological, technical, and people excellence put into this model, and we are trying to make this model get converted so that we can have the highest returns coming out from the knowledge segment, then specialty, and basic chemicals. Obviously, because of our large population base, will continue to be there. But yes, if we have to survive and we have to excel, we have to increase our knowledge segment based chemicals, and we have got very strong enablers in this regard. The foremost enabler is that we have to improvise our R&D productivity. We have to envisage the future challenges, like we can say from the Grace presentation, the new chemicals they have prepared, the new Zavanti and other innovations they are doing. So they have envisaged the future challenges. Similar is the way we are also identifying the future challenges and we are working to achieve them. We need to have long-term goals and sharp focus because in this chemical industry, the results doesn't come over the overnight. And unlike our counterparts in FMCG or say fast-moving electronic goods, we have to keep long-time vision to be successful. We have to continuously explore opportunities for expanding, like Indian Oil. Then when it has decided to expand beyond refining into a petrochemical, so we have to keep on looking opportunities to expand, to keep abreast with the happenings around, and to have the technical and edge in the operations. And we, any organization, if it has to grow, it can't grow by looking only inward. We have to look beyond, and we have to have some sort of agreements and joint exploration programs with commercial organizations and academia. And Indian Oil again is a front leader in India from this aspect, and Indian Oil R&D itself has got number of MOUs with the commercial organizations across the globe, for which we are working for joint development and some technology demonstrations also. Regarding academia, also Indian Oil, we have got agreements with a lot of academia, and just to give an example, we run joint PhD programs with IIT Delhi, and I also happen to be guiding one student. So it allows us to expand our credibility and also expand our expertise. And if we talk about the innovation, we have got a very beautiful R&D center at Faridabad, and you are welcome to visit it sometimes. It is at south side of Delhi, around 35 kilometers from the Delhi center. And last year in May, this was the two experts which I have put on it. The first one is in the energy world, where it was declared that we are the first PSU in India to cross the 1,000 patent milestone, and that was a very big step for us. And probably next 1,000 will come in a much shorter time. Sorry, on the right is the excerpt from the Mint, in which the underline was that the R&D team has made considerable progress even in the highly IP crowded field of Zignata Catalyst. And this is a very proud statement because I am leading the Indian Oil efforts in Zignata Catalyst. And in very short span of time, we have made a lot of ingress in and contributed to the growth and development of the Ignita catalyst field. And at our center, Petrochemical and Polymer Center, we are working under different platforms, and every platform we are championing intellectual property. Every program is innovation driven. We do the things differently. We look the things differently. So the Ignita catalyst development, we have some specialty products coming out from like drag reducing agents, polyalpha olefins, 4 points, olefin copolymerizations. We are doing new grade development additives. And also we are working on a lot of petrochemical processes and catalysis, including the linear alpha olefins, on which we have got very good success. Being very environmentally conscious and a sustainable focused company, we are also working on how we can do the mechanical, chemical, plastic waste recycling, specialty products like polyisoprene and many other chemicals. And this figure I'm proud to share that in our department only, which started in 2010, we have filed more than 100 patents, and out of it, 82 patents have already been granted. And this is a big number in a span of time in which we have started to work. Now, coming to the polyolefin catalyst, to give a brief overview, that PP polypropylene is, as in last presentation also we have seen, that a lot of focus is on propylene. So maximum of the propylene is getting consumed for the production of polypropylene. And polypropylene catalyst market is expected to reach around $1.5 billion by 2022. And it is growing at a healthy rate also, which is more than 5% CAGR. And in the PP catalyst, the Ignita catalysts are the most preferred catalyst type. And in India, most of the production is based on the Ignita catalyst only. And this is a short purview on the ZN catalyst. And coming to the Indian oil, why our stakes are high for the polyolefin catalyst? The reason is that we are the second largest producer of PP and P in India. We are operating one 300 KTA HDB production line of hosting technology at Panipat, and we are operating 1300 KTA Spherical technology lines at Panipat and Paradeep. And when our management has given us a mandate, now we have to develop the catalyst systems for polyolefins. The natural way to do was, first we did the lot of literature analysis, what all our competitors are doing. So we identified that each of, say, catalyst producer has got its own catalyst precursor, which are listed. Few of them are listed on the left-hand side of the screen. And each company has got their own patent portfolio built around these precursors. Now, what is happening? Say, for example, companies like Basel, Mitsui, BSF, and now even Clayton, everybody is using magnesium dichloride, MgCl2. Again, the mandate was given to us to develop the process for this catalyst production. We decided that let us keep our targets high for the innovation, and we should target a novel precursor so that we don't have any dependence on the exotic raw materials, and we can start the catalyst synthesis with the simple, easily available chemicals, which is within India also. So we were able to develop the novel technologies for producing magnesium precursors, which is the heart for the total catalyst in say polypropylene and polyethylene. And these catalysts are highly specialized catalysts, and we can call them, they are molecularly assembled, and crystallized size is very small. When people are excited with the nano range, these catalysts have got crystallized size typically ranging between 40 to 75 angstrom. And the catalysts which we have developed have been extensively evaluated by third parties and benchmarked against commercial offerings. And more or less on the every performance benchmark, our catalyst has exceeded. And again, 82 patents have been granted based on this unique chemistry, and the chemistry which we extended this chemistry to our other fields also.
Dr. Gurmeet,
yes, sure, sir. And in this thing, we have developed two different precursors, and these precursors are unique to IOCL and they are patented. And they have given us the right catalyst systems for the polypropylene. And these are the few of the parameters which we have identified. And the catalyst systems were benchmarked by a third party. And this is the data from a Norwegian company. So in the productivity benchmarking and the other aspects like donor response and hydrogen response, our catalysts were found to be superior over the commercial offerings. And also we have extended this precursor technology to the polyethylene catalyst also. And again, the catalysts have been evaluated extensively in-house and also by third parties. And the catalysts have exceeded the productivity and hydrogen response because of any commercial catalyst. And both the catalysts are now under at present commercialization. And the same technology of the catalyst we extended to produce an entirely different class of polymers, which are the drag reducing agents, and they have got very high molecular weight of more than 20 million daltons. And we were able to make this product using alpha olefin polymerization. And this product has been tested at pipeline, and they have given excellent results. And this, after multiple commercial trials, the technology has been established. We have got a patent also on this technology, and currently this technology is under commercialization. And now innovation, now we are also moving from in vitro to in silico, and we have established molecular modeling at our end. And we are using this density functional theory models using HPC clusters, high performance computing clusters. And we are using this model to funnel ideas so that we don't have to do a lot of bench work, but at least we can filter. If we have 100 ideas, we can filter 10 ideas. And then only those 10 ideas are extended to the actual bench work. And in the conclusion, our research foray into petrochemicals is purely based on innovation. We are not building upon any others' patents or knowledge. We are creating knowledge. And we have robust precursor we have developed using extensive, we have used the state-of-the-art technologies like parallel and automated processes. And both the precursors have been established for the production of high activity, high productive, high steel regularity catalyst for producing PP and polyethylene, both for polypropylene and polyethylene. And both the catalysts have shown excellent performance with the desired product characteristics also, which is also very important. And application of molecular modeling has been initiated to understand performance and funneling ideas. And all our innovation is extensively protected. Uh, thanks. Thanks for this opportunity.
Yeah. Thank you, Dr. Gumi Singh. Can I request to go ahead with his presentation now?
There was small hiccup or I would ground level reality of digitalization. So now I'm trying to make my presentation. Can you able to see my screen and can you able to hear me well? Can you able to hear me, sir?
Yes, yes.
Okay. Thank you so much, sir. Good afternoon, respected sir, Mr. Arvind Kumar ji, and my fellow speakers, Mr. Gary and Dr. Gurmeet, and ladies and gentlemen who is participating in this virtual seminar. Thanks for everyone. My special thanks to Mr. Gary, my previous speaker, as he made my presentation easier by explaining the technology which I'm supposed to explain. Thank you so much. So probably I may take a little lesser time to walk around. First of all, I would like to thank GRPC for providing such a good opportunity to present in this forum in a safer manner, basically COVID safe manner from home office. And today I'm going to present our step out technology in hydrocracking catalyst side as a nano engineered zeolite. Just now Mr. Gary has explained about their Rive platform, so similar to that, this one in hydrocracking catalyst side. So why we should talk about nano engineered zeolite? There was always, we were trying to get most out of the hydrocracking catalyst reactor or catalyst. So in good olden times we have started with the macro side, that means the contact efficiency between hydrocarbon liquid and the catalyst particle. So that's where we were trying to improve. That was a macro scale. So the examples were the design development of reactors, chambers or reactor internals, development, efficiency improvement. So those are all in macro side. Then went our R&D went into micro scales, which is probably catalyst formulations. We were trying out a lot of different catalyst formulations, starting from few formulations to thousands of formulation per year. So now we are going more into micro to nano level, which is catalyst particle levels. We are trying to synthesis or fabricate the catalyst particle so that it favors or it does only the required reaction. So that's where we are into. So nano engineered zeolite. So this is I would say this is going to help the refiner to face all these kind of challenges what we have talked about so far. Don't worry, this is not a eye test for you. It's just a cautionary note from our side. This says that this is a technological presentation. Please do not make any investment decision based on this slide or this presentation. Today I'm going to talk about why we need an enhanced zeolite, and I'm going to introduce our new technology. These two has been covered a little bit by Mr. Gary as well in their RIVE technology. Then I will show my our shell catalyst and technologies React portfolio along with some case studies. Then finally what it means to you. So with that I'll conclude my presentation. So from the morning you might have listened to various eminent speakers talking about the challenges in front of the refinery. It's not only challenges in front of the refinery, challenges in front of everyone, every single human being in the world. It involves so basically it starts with the volatile margins on uncertain future. Today is a perfect example of this volatile margin and uncertain future, the COVID situation. So we don't know where we are going or where the refiners are going, the uncertain future we are having. And IMO 2020 or clean fuel regulations or any other environmental regulations, it's a kind of nowadays it's very standard for us because we have been under this kind of pressure for 20-25 years. Then declining on shift in fuel demand, especially when we are moving into newer energy demand or energy transition, this is going to be a new challenge in front of us. Finally, competitive fuel commodities market. This forcing us, all the refiners, to move from commoditized fuel to specialized fuel. So these are the challenges in front of us. Hydrocracker. Hydrocracker was helping the refiners to face some of the challenges in the past decades, and it will definitely help the refiners to face some other challenges in the future as well. So basically it's very simple. How is they have to process low value feed and convert them to high value products. It's as simple as that. Is everybody knows that. So low value feed in the sense basically advantaged crude like heavy crudes or some nasty crudes or high tan crudes or high residue containing crudes, or otherwise the difficult feeds like heavy FCC feeds or heavy feeds from resid hydrocrackers. So those kind of basically this distrust feed they have to process while achieving more and more differentiated fuels, or more and more specialized product which gives more value to the refinery, from which they can add more, improve their margin. What is the net results? That adds more and more operating severity to the hydrocracker, existing hydrocracker. So how to to address that issue, how to overcome that challenge in front of them in terms of hydrocracker. Again, it's very simple. Means basically they have to, or we have to improve the efficiency of hydrocracking catalyst cracking ability. But how to improve that cracking catalyst ability? So that's a challenge in front of us. We had when we were doing the R&D. So as most of you know, hydrocracking is a simple three-step reaction. Dehydrogenation, then cracking, and the hydrogenation. So dehydrogenation and hydrogenation is supported by the metal function, and the cracking is supported by the zeolite function. So we need to restrict the cracking to till our favor position. So the traditional conventional zeolite is somewhat giving, it's not optimal for handle this high or heavy or large molecules where we have margins, or where we have refiners can get more margins out of that processing. So conventional zeolite is suboptimal, and the molecules, larger molecules spend too much time inside the zeolite, and it increases the risk of overcracking. So we were set out to create a new material that could allow the large and heavy molecules to the zeolite side, so that it can produce more valuable product. And we are now finally achieved, and we are proud to introduce our MAC catalyst, molecular access catalyst for hydrocracking. It's, again, as I said, nano engineered catalyst. It's a hard work of 5 years of R&D journey, and finally we have scaled up and commercialized. Now it's available now in the market. And during the process of our journey, we found some unpredicted or unexpected surprises, which was giving more value which can give more value to the refiners. So this, I think Mr. Gary has explained a little bit, but let me explain as well. So the conventional Y zeolite, which is in the left-hand side, picture A, has a lot of micropores, and which has a smaller size micropores, which does not allow the larger molecules to get in and get out. But the Y zeolite, or processed Y zeolite in the right-hand side, picture B, you can see from our R&D, we managed to put a punch in the middle of the micropores, which called mesopore. So mesopore creates very good path for the larger molecules to allow get into the zeolite and create more and more valuable product. So diffusion makes the diffusion very faster. So from this you can see the left hand side, the conventional zeolite, the lighter area are the macropores, and the dark sides are the micropores. So and this is the picture A is the parent Y zeolite, and picture B is mesoporized zeolite, the MAG zeolite. So you can see the light pores are mesopores, and this gives a very good homogeneity. So homogeneity means it's basically we are utilizing the complete zeolite, and also we can fine tune the pore size and pore distribution, so that shows that we can tailor made the zeolite for specific application. So how does it help? So as we have said, the conventional isolate has some limitation in handling the heavier molecules. So as you can see this plot, the effectiveness of the cracking goes down with the heavy molecules, heavy end of the molecules. So very drastically, its effectiveness goes down very drastically. With the new material, the effectiveness improves a lot. Basically, the molecule has less distance to travel, or one third less distance to travel, and the diffusion rate is very high because of this mesopore, and a lot of entrances and exits to the cracking side. That this increases the diffusivity of that larger molecule by 9 times, so 900 times effective catalyst. That's why we call it this as a step out catalyst. And we try to put it as a small animation over here. If To explain this concept, if you see there are two molecules coming in, color coded with blue and red. The blue molecule very easily fits into the micropores, whereas red molecule does not. So it takes the route of the mesopore, which big opening. So it goes in, and it now it's de-aromatization is happening, and the red molecule comes out very quickly before the blue molecule comes out, and it comes out as a one single molecule, whereas the blue molecule comes out as a two smaller molecule. So that basically this is the concept of this technology. Mesopores gives better accessibility for the zeolite. So as I said earlier, we have commercialized this technology. We have three catalysts in using this technology, namely HD27, MD07, and MD17. So molecular access catalyst for hydrocracking. Typically, the hydrocracking catalyst portfolios are.
Last 2 minutes to summarize, please.
Yes, sir. Typically, the hydrocracking catalysts are given in the two-dimensional plots, so that we have given over here. But this MAC catalyst has a lot of advantage beyond this two-dimensional. So I'm going to have just brief three different case studies for. So basically, our catalyst can be applied, or this technology can be applied irrespective of the configuration, whether it is a single stage once through, or single stage recycle, or two stage. So the first case study is for single stage once through 140 bar pressure. In this you can see the selectivity, middle distillate selectivity is higher than the conventional catalyst by 1.5 to 2% at the cost of lower naphtha generation, which is really good, so that refiners can make money. And the diesel to kero ratio is better, so it again shows that there is no overcracking in the zeolite, and also it ensures that stability throughout the cycle. And you can see the unconverted oil has high VI, so which makes the feed which makes the product very suitable for lube application. And also the hydrogen content of unconverted oil is very high, so which makes suitable for all kind of petrochemical feedstock, like steam crackers, ethylene crackers, or FCC, which gives very better propylene or ethylene yields. This adds a lot of value to the customer. The case study 2, again, a single stage unit with a higher amount of heavy feed. Here you can see this gives very high end conversion, heavy end conversion. Basically, this cracks the heavy end and makes it to middle distillates compared to the conventional cracking catalyst. So this gives basically improved stability of the catalyst throughout the cycle. We have seen in our pilot plant also the spent catalyst has been analyzed for coke and hydrogen content. So we have seen less coke and high hydrogen content. It's again established that it can give very stable operation throughout the cycle. And third case study is basically for two-stage unit. In addition to heavy end conversion, you can see reduced polycycle aromatics in UCO. Basically, this gives again stability over the cycle. For the two-stage operation, stability is very important. So compared to the base catalyst, you can increase the conversion by 3%. So the base case has been, the data has been generated for at 97% conversion. So with this new generation catalyst, you can run at even closer to 100% conversion with the same stability without any issues. And finally, it also increases the hydrogenation, so that increases the volume gain and produce premium products. So what this mean to you? Basically, this technology produces more premium fuels as expected. Also, in addition, so it gives a lot of other advantages. As I said, different dimensions of the advantage by which refiner can improve their margin. Basically, this gives enough opportunity to increase their profitability and flexibility to adopt change in environment, tougher environment. So that's all I have. Thank you so much.
Thank you, Mr. Ram Babu. Just to summarize, the three learned speakers have told that start with the Mr. Gary Chang. He has talked about the next gen FCC catalyst of the RIVE technology. That's the lowest dry gas, best coke selectivity. And then the ZSM5 technology. They started 1984 with the mobile, and Zavanti is the latest technology. So that can be fruitful. And then Dr. Gurmeet Singh from R&D IOCL, he talked about the innovation and the emphasis on the more patent filing with the China and Korea, they are leading. And he also mentioned that IOCL became the first PSU to cross 1,000 patents milestones, and Make in India initiatives the IOCL is taking, and the need to take from basic chemicals to knowledge-based, knowledge segment chemicals for the higher returns. And he also talked about the novel technology which IOCL is going to produce of Ziegler-Natta catalyst in polymerization. And so he emphasized on the Atmanirbhar Bharat. And then Mr. Ram Babu Raja, he has talked about the hydrocracking catalyst to improve the catalyst efficiency. And as the conventional zeolite is suboptimal, he has talked about the Shell developed the MAC catalyst, this nano-engineered catalyst, for more valuable products. So these are some of the learning from these three learned speakers. And now we can look quickly to a few questions. And there's nothing in the chat box. Anisha, you can help us.
This discussion, we have no time, unfortunately, to take the questions. So I would like to thank you and all the panelists for joining us today, sir, and taking and if for those who have questions, we request them to get in touch with you directly regarding the catalysts that are working well, and what are the innovations there, what are the benefits there. We request all, if anybody has questions, to kindly get in touch with the speakers. Thank you to all of you for joining us today and sharing with us your expertise and wealth of knowledge on how to decide upon the catalyst that works best for you. Thank you so much, sir.
Thank you, Anisha. Thank you so much, gentlemen and ladies. Thank you. Thank you,
Thank you,
audience.
sir. Thanks, everyone. Thank you. Bye.
So now we're going to move on to another technical session, and this is the last technical session of the day. Again, this one is fairly important. We are going to be talking about operations and process technology innovations. And speakers are joining us. In fact, we have 3 of them here. So I'll just give a quick introduction and then I'll hand it over to our session chairman. Now, industrial safety is not a one-time affair of just laying down the rules and implementing them. Now, processes need to be fine-tuned, especially with newer technologies. Whatever is obsolete needs to be done away with. And the safety culture is one that has to flow from the top and has to be drilled down to the last worker on the shop floor. Now, for this discussion on process technology innovations and operational excellence, please welcome Mr. S. Bharathan, Head R&D, Hindustan Petroleum Corporation Limited, who is the session's chairman. Please also welcome Mr. Alok Saxena, Managing Director, Sulzer GDC Technology. He'll be speaking about a new process for purified styrene recovery from pygas. We also have with us Mr. Rajesh Samarth, Vice President, Lumens Technology. He will speak about olefin conversion technology, a sustainable path to polypropylene. And we have Mr. Anuj Jain, Director, Business Development, KBR. A warm welcome to all of you. I see that we have all of them online, and I'll hand it over to Mr. Bharathan to take this discussion forward. Over to you, sir. Mr. Bharathan, we are not able to hear you. Can you unmute yourself?
Yeah, very good afternoon to all the participants and to the panel members for this last presentation of the day. So today the topic is process technology innovation and operational excellence. The prelude of that was already given by the moderator. So this process technology innovation, operation excellence, all are focused on yield maximization, energy minimization, process intensification, all this in a reliable and safety way. So reliability and safety are to be maintained to achieve the major goals of any refining industry, which is yield maximization, energy minimization, also process intensification as we go along the competition, and the footprint also has to be optimized. Now the new dimension is added to this, that you should do all this with nil emission. So this will become the order of the day, and further and further we will have to be reduced various components we may have to keep controlling. Right now we are totally removing sulfur oxides. Tomorrow slowly there will be a day where even carbon dioxide will have to be totally eliminated. So that will be a future challenge. When we do all this, we get sustainable performance and the companies move ahead. So this process technology innovations focuses on providing better solutions that meet these new requirements as well as to sustain the existing market needs. Similarly, operational excellence and operational innovation is a way where organizations try to change their operational platform to remain in the business and to get that final mileage, which is easily comes without any additional investment. So that is a main key differentiator. Today we have with us 3 speakers who are all well known in the industry and very close friends of mine. So without, we will straight away go into the presentations and hear from them, and then we can sum up with their key presentation points. I will now request Dr. Alok Saxena of Sulzer GDC Technology to give his presentation on new process for purified styrene recovery from pygas. Over to you, Dr. Saxena ji.
Thank you, Dr. Bharathan. I'm thankful to the organizers for giving this opportunity to present on styrene, our latest process, as a part of this in this session of process innovation. Right now, are you able to see my screen? Just am I audible?
Yeah, you are audible, sir, but your screen is yet to come.
Okay, okay. Just a minute. I don't think it is coming. Just a minute. This it's kind of getting. This is
Alok sir, you just have to share the presentation and it will come there, okay? You just share your screen, I'll help you out.
Okay, fine.
Yeah, just share your screen, I'll tell you when it is appearing at our end.
Okay, fine.
Share it.
Is it sharing now?
No, earlier your screen was coming, now it is
Okay.
not. Please share once again.
Okay.
There is a share button at the bottom.
Yeah, yeah. I'm just clicking that only.
Yeah, just relax and just do it.
Okay. It's showing multiple times. It looks. I think you can switch over to next speaker. I'll check, get it done in between.
Okay, okay, no problem.
Okay, okay.
Probably we can start with Rajesh. Rajesh is Vice President, Lamas Technology. He will be talking about olefin conversion technology, a sustainable path to propylene. Rajesh, you can start.
Hi, thank you, Mr. Bharathan. So to you for the introduction, and it's good to see you in person. This COVID has made it difficult for all of us to meet. So good to see you as well as the other eminent speakers over here. It was a delightful experience today to see many of the speakers. Are you able to hear okay? I'm hearing some feedback from myself.
No, you are able, you are clear. You can start sharing your screen. Yeah.
That's what I'm going to do. Just an issue here. I have some issues saying it's not responding.
So just refresh the screen once, please.
Yeah, that's what I'm trying to do. It just become, the whole thing has become gray now, and the live studio restream Google Chrome, I get like not responding on the top there.
Just cross it and refresh it once. It should be working fine.
This didn't happen when we were checking the system check the other day.
No worries, sir. I request you just refresh it once and just share your screen. We'll be helping you with that. Yeah. So he'll be just joining in a few minutes. Just stay tuned. Welcome back, Rajesh ji. Can you just try it now?
Yeah. Applicant window, right?
Yeah, we can see you and hear you.
Are you able to see my presentation at all?
Yeah.
You are? Okay. Good. You can see my presentation, right?
No, we cannot see your screen.
You cannot see my screen.
Okay. Okay, Rajesh ji, I'll suggest you something. You can mail me your presentation. Meanwhile, Anuj sir, are you ready with your presentation? Anuj ji, can you unmute yourself? Yeah.
Okay. Yeah, I'm ready with my presentation.
Please share it. Meanwhile, we will try to sort it out with Rajesh sir.
Yeah.
Invitation for this?
Yeah, we can see.
Okay.
Yeah.
We have now with us Mr. Anuj Jain, who is Director Business Development KBR. He'll be talking about KBR innovative process technologies, addressing refiners' challenges. Okay, Anuj, your presentation is visible and you are audible. Please go ahead.
Thank you, Mr. Bharatan, and very good evening and good day to all. First of all, I would like to thank organizers for providing this opportunity to connect. Also privileged to join with Mr. Bharatan and with my fellow speakers in this session. I would like to start, I would like to take you through KBR journey and will present KBR's innovative process technologies addressing refiners' challenges. So, as you see in the graph, left-hand side of the graph, there is a declining trend for transportation fuel, both for diesel and gasoline. And this declining trend, one of the main reason is because of significant shift from hydrocarbon fossil fuel to non-fossil fuel, which is mainly led by renewable energy in form of solar, wind, and many other forms. So with this declining, nobody knows what will be the pace of this declining over the years, but directionally, it is sure that this is going to decline in next coming years. On the other hand, you can see fuel oil, and this fuel oil has also been declined from last many decades. And with the implementation of IMO 2020, for the bunker fuels, it is expected that it is going to decline further and will be reduced in future. Now, the resultant of all these trends is basically, you can see that we have excess naphtha in the refinery, and this is almost a direct result of that. And also, if you see in the right hand side graph, there is a increasing light olefins demand, which is also basically you need naphtha to meet the petrochemical demand. And the demand for petrochemical is mainly driven by GDP, and countries like India, China, and Asia Pac region with growing population are driving this trend. So with this, we can see that there are we have certain trends of in product slate, and with this, it looks like that refiners to seek some degree of petrochemical integration over the foreseeable future. And the key process technologies that will be the focus for the adaptation are many. And in my presentation, I'm going to go through few of those technologies which can address these uncertainties in demand. So going through this ROSE. ROSE is KBR's solvent deasphalting technology. This is one of the solutions to reduce fuel oil generation. And with the ROSE unit, basically it converts residue into high value feed, which is DAO. This is an additional feed for conversion units like hydrocracker, mild hydrocracker, FCC, RFCC, and other units in the refinery. With the help of this feed, I mean, it saves expensive feed which is going to these units in place of this. Then we have certain products out of these units which are C2C3 olefins. Basically, these are the destination for score and cracker and Maxophene technology. Then we have C5 olefins coming out of these conversion units, which can be used for additional high octane gasoline with the help of KSAT technology. We have naphtha distillates, which can be additional transportation fuels, and also lubes for bright stock. So these are various components which are coming out from these conversion unit. Now from ROSE unit, we have also pitch coming out of it. And that pitch, we have several routes to handle that pitch. One of the route is to route this pitch into resid hydrocracker or delayed coker unit, or also a VCC, which is Weber combi cracking, a technology by KBR. From that, you can convert this pitch into naphtha distillates, and that can be used in additional transportation fuels. So now, till now, you have seen that putting a ROSE unit, you get additional feed and several various components out of the conversion unit. Now we have to see how to handle the pitch in some other options. So one of the options is AIMS, which is Asphaltene Integrated Management System. Here, pitch will be solidified and it will be converted into flakes. And these flakes can be used in cement industry or steel industry as a fuel. KBR has a modularized solution for this unit, and it can be very well integrated with ROSE unit. Another option is to use this pitch directly for power and steam generation. And with this, we have a solution for asphaltene integrated system, which is a pitch boiler. We have a collaboration with Mitsubishi, where they have running units where ROSE pitch is connected to the boilers, and 3 units are running in Japan. Other ones, we know that this pitch can be used also for making bitumen, and with all this, definitely we are going to reduce fuel oil generation. So overall, if we see that with the ROSE unit, we can monetize every barrel process in the refinery. And also, there are several solutions available, and we have commercially proven scheme for pitch and residue handling in the refinery. I'm going to talk about FCC. And FCC, KBR is pioneer in FCC technology. KBR developed the world's first known commercial FCC unit at Louisiana in 1942, and also designed some of the first VGO and resid crackers. Since then, KBR has executed more than 120 grassroots units. And if you see the timeline from 1942, 1961, we have come up with resid FCC. Then in 1998, Maxophene, which is mainly to produce propylene. And in 2006, we came up with a new disruptive technology, which is K-COT. Here in this technology, we can use C4, C9 olefinic stream, and reactor, we are using the same reactor which is in FCC with some changes in risers, temperature pressure conditions, and proprietary catalyst. So with the help of that, we can produce more propylene than ethylene. And K-COT can be integrated along with cracker and also as a standalone unit in refinery and petrochemical configuration. So this is a quite unique technology, and this will give more propylene than ethylene, and we can get a ratio of up to 2:1. Commercially, this unit is well proven. We have running reference unit, and we can take benefit of this technology going further. Another technology in 2013, which is max LCO process, basically to produce more LCO product. And then recently in 2019, we have developed K-Pro, which is propane dehydrogenation. And again, we are using the same orthoflow reactor coming out from FCC with the different pressure, temperature, and proprietary catalyst. So feed will be again propane for PDH unit, and product is more propylene. So the idea to show you this timeline for FCC is that over the past 70 years, we have come out with a lot of innovations and improvements to FCC units, providing different solutions in refinery and can be integrated with petrochemical units. Another technology which I would like to talk about, as we are moving towards stringent environment norms, more and more hydrotreating is being done. Hydrotreating reduces sulfur, but at the same time, it also reduces octane. So KBR solid acid alkylation technology, KSAT, maximizes the yield of motor fuels and enhances production of an ultra clean blend stock, which is alkylate. Here, if just quickly we can go through this process. The feed is basically the C2 to C5 olefins together with isobutane, and in presence of a unique solid acid catalyst, we can produce alkylate in the reactor. So it's a 2+1 reactor scheme where 2 reactors are in operation and 1 reactor is in standby for regeneration. With this, this alkylate, which is we are going to get from this unit, is of higher octane than that obtained by any other liquid and solid acid catalyst under a wide range of process conditions. It's a simple process, low capex, and we can look into few key advantages of this process. Basically, this is very flexible to process C2 to C5 olefin feed, and the catalyst is proprietary from KBR, and it is precious metal free. It is basically a zeolite based catalyst, so very good for OPEX and an environment point of view. We have complete modularized solution for this unit. So the unit is very compact with less number of equipment than any other competitive technology. And the catalyst is of 5-year guaranteed life. The regeneration cycle required is more than 24 hours, but actual regeneration time is quite less, which is almost 12 to 16 hours as such. This technology is also commercially proven. We have references, and many projects are in pipeline in design phase. I would like to touch upon another technology. KBR introduces MaxIsom as a technology innovation for low-cost production of high-octane isomerate gasoline is in highly flexible and compact energy requirements. As you can see on the screen, it's very compact with a very low number of equipments. It basically uses regenerable catalyst that isomerizes and separates the isoparaffin products while recycling the normal paraffins over the catalyst reaction zones within the same distillation column. So we have one column for the entire feed, and the last bed will handle C7 and benzene saturation, whereas the first and second bed will handle C5 and C6 stream. This innovative design offers an energy efficient, compact, and low capex alternative. This is basically can accommodate high benzene content, which is approximately up to 20%. And if you see the other competitive technology, those are limited to 5% of benzene. Also, it can handle some amount of contaminants. We can look into a few other key features of this technology. It's high selectivity, lower capex or OPEX, lower footprint. As we have seen, it's a very less number of equipments involved in this technology. It basically, this MaxISOM fits for both grassroots and revamp scheme. So the revamp option is also very less capex incentive, and it can be installed, it can be implemented in any of the available technology. It's a more efficient process with maximizing octane. It can process C5 to C7 feed. As I said earlier, higher limit on benzene and high tolerance to contaminants. Also, I have shown only one scheme on the screen, but there are many different configurations that can be tailor-made to a refiner's need. Commercially, this technology, we have a pilot plant running, and a couple of plant we have designed, and one of the plant is actually equipments have been ordered, but construction is currently under hold. So as of today, we don't have running reference, but we are in discussion with a lot of clients to come up with a unit very soon. Another technology which I would like to cover during my presentation today is Weber combi cracking, which is VCC. Is capable of processing a variety of feedstock from refinery residues to coal with 95% conversion in a single pass. It's basically VCC is a slurry phase hydrocracking process for higher conversion, and it basically processes low value streams, whether vacuum residue, SDA pitch, slurry, oil, or coal. The process is very simple in a way. It's a two-stage process where first stage reactor is converting the residues into convertible products, and this first stage reactor is non-catalytic, and the products which are converted from the first stage goes to the second stage, where we have a fixed bed. It's a fixed bed catalyst reactor, where the hydrotreating and hydrocracking of the converted products will happen. So with the overall scheme, we can see that the conversion is very high, and from the low value streams in the refinery, we can get LPG, naphtha, distillates. So it's a very optimized and very unique technology with us. The key advantages of this technology, again, it's a very high feed flexibility. You can put any low value stream, any kind of residue. No catalyst required for first stage, as I just mentioned. Of course, high conversion, 95% and above. Once through operation and production of directly marketable products, as you can see in the right-hand side table, the quality of products, naphtha, diesel, and VGO. We have numerous residue handling options and, of course, high return on the investment. Just commercially, VCC technology is also commercially proven. We have one running reference unit with the refinery residue, and we have 2 units running with coal and other residues. So just to sum up my presentation today, I would like to cover with some bullet points. Technology innovation is a continual process with a long-term technology landscape. We need to look beyond what is new to what's next. And innovative technologies and operational flexibility is a key requirement to address demand uncertainties. We expect that residue upgrading, steam cracking, and product upgrading technologies like alkylation and we will be the focus for adaptation and essential to survive in the future refining market. KBR has some innovative technology solutions to address refiners' challenges. Thank you.
Thank you, Anuj, for your excellent presentation on the new configurations that are available. I think mainly ROSE, VCC, then your propylene maximization, and maximum ISOM technology using catalytic distillation, finally modularization. All this will go a long way in creating innovative solutions for the refiners. Now I will request Dr. Alok Saxena to share his presentation and start. Dr. Saxena, please. I think the next 2 presentations can take about 12 to 14 minutes so that we can have 1 or 2 questions and then wrap up. Yes, Dr. Saxena.
Alokji, I'm just sharing your presentation. Please hold for a second. And please unmute yourself.
Fine.
So here you go, sir. We are live with your presentation.
Fine. Thank you. So thanks for the opportunity to present this styrene extraction technology, GT Styrene 20. Actually, this is a innovative solution, well fits in this session of technology innovation, where we are presenting process for ultra pure styrene monomer recovery from cracker pie gas. I would like to underline ultra pure. Let's go to, yeah. If you see, styrene is normally produced by EBSM route. This is ethyl benzene dehydrogenation. 80 to 85% of what global capacity is produced using this technology, and cost of to produce is about 795 euros per ton, because it is quite energy intensive technology requiring distillation separation of styrene from ethyl benzene in series of columns. Other technology is POSM technology, which contributes about 10 to 15% of the global capacity. It is peroxide route. It produces propylene oxide also, and because of that credit, this cost is slightly lower, 655 euros per ton. The extraction of styrene is actually available in pie gas in substantial quantity, and it can be extracted, and production through this route is about 2%. And because this molecule is readily available, it costs about its cost of production is about 555 euros per ton. These are the details from Wood Mackenzie Chemical Petrochemical Market, April 2020. So it's not very old information. Going to the next slide. Next slide here. The potential of styrene in basically in the when we are talking of integration of refinery with petrochemicals, this type of configurations are obvious, and more and more crackers are coming, and from this cracker, pie gas has a potential of styrene from which it can be extracted. Next slide. If you see, normally what happens in a cracker, C8 pi gas is hydrotreated, then it is extracted to produce benzene, toluene, and xylene. In this case, there is no production of styrene, and any styrene present in pi gas gets saturated in this hydrotreater. It is very important to maximize the value of pi gas based products, because once these cracker complex have to compete with gas based cracker where the yields of ethylene and propylene are much higher. Unless we add the value to this pi gas byproducts, these crackers will not be competitive with other world size crackers based on only on gas. So this valorization can be further improved by extracting styrene from this stream. Can we go to the next slide? Yeah, styrene can be produced if we take this C8 hard cut to recover styrene, and raffinate is recycled back to the hydrotreater, and rest of the things are produced as such as in the conventional configuration. So it's a very good fit in here, and advantages here, once we take the styrene out through this extraction, it upgrades the xylene quality. Mixed xylene of isomer grade is produced. Without this extraction, it is solvent grade oxidation because of high content of ethyl benzene there. And at the same time, once we recover the styrene here, hydrogen consumption here is in hydrotreating unit is also reduced, and there are other advantages in the operation of this hydrotreater. So this way we are adding to the value as well as improving the performance and other measures in the in processing of C8 cut. Next slide, please. For a steam cracker, if you see the potential of styrene, if it is a 1 million ton ethylene from liquid feed cracker, it has a potential up to 35 kTA of styrene monomer. Historically, this styrene recovery from pi gas was not considered because right technology was not available, and ethylene crackers were not large enough to produce styrene of economic scale. Typically, if we have 1 million ton cracker, it can give the sufficient size to produce styrene in styrene on economically viable scale. Next slide. To extract this styrene, what is important? It has to be extracted from a mixture of paraffins, olefins, diolefins, aromatics, and aromatic olefins. And these are all close boiling. Let's go to the next slide. If you see, this is the styrene molecule, boils at 145 degrees centigrade, and if you compare the other molecules, it's very close, 136, 144, 142, 139, 152. So recovery of this styrene through distillation is not a feasible way. Next slide. This gives the idea about the relative volatility of styrene with respect to other competing molecules from which it has to be extracted. If it is distillation, relative volatilities are of the order of 1.3 or 0.6 in this range. However, if it is done extractive distillation in the presence of solvent, we alter the relative volatility significantly, and it's possible to produce styrene from C8 pi gas cut. Next slide. So to alter the volatility, large increase in relative volatility is essential. It has to be done in the presence of a solvent. That's why it is extractive distillation, and Tactive 200 is the solvent which is used to alter this relative volatility and produce styrene. Solvent should be thermally and chemically stable and must be conveniently separated from styrene. Through intensive research and process development, Sulzer GTC has designed an optimum solvent blend, Tactive 200. It is customized for this styrene process. Next. Separation of styrene monomer from close boiling components using Tactive is still the core of the process. This process is GTC has been licensing and already 3 units are commercially operational, and core process still remains the same, which is extracted distillation using Tactive 200. It includes post fractionation. Finishing includes 4 different processing steps. One can produce styrene using in conventional way using Tactive 200, but it requires 4 different steps, which has to meet color requirement, sulfur requirement, oxygenates, heavy and polymers. So these 4 steps are not that elegant, and through the innovation at present, GTC has come out with a process in single processing step of crystallization. This is the innovation which is presented in this here, so which reduces these 4 steps to 1 step and reduces the capex and opex for this process. Next slide. If you see the first generation process, Pygas C8 hard cut was polyacetylene was hydrogenated, and it is the extractive distillation step, extract EDC as well as solvent regeneration. From this extract is subjected to these purification steps, which includes color removal, oxygenate removal, and sulfur and heavies removal to get 99.8% of styrene monomer. Next slide. Actually, if you see styrene purity as required by the is achievable here, which is 99.8%. But to meet other specification of the styrene, these are the polishing steps required to convert to the marketable product. Next slide. This ASTM D2827 specification styrene basically requires 99.8%, but at the same time, these are the color and other specifications which have to be met, and those polishing steps are there to basically meet all these specifications. Next slide. Though in this GT styrene 20, the second generation current extraction process, all those polishing steps have vanished and replaced by one crystallization based process. This is a fractional crystallization which allows to pure ultra high purity of styrene, that is 99.958%. That time in previous generation we are talking of 99.8%. Other advantages are new approach for final purification of the styrene, one step crystallization versus multi-step processing. The crystallization makes ultra high purity product meeting all the specification. Nominal purity is of the order of 99.95%, and total sulfur of less than 5 ppm is possible. Next slide. This was a process flow diagram from the previous generation, which was after this styrene dehydration. It included clay treatment, styrene finishing column, and falling film evaporator. All these operations were involved to polish the styrene to the required specification. Next slide. If in the next generation all those steps are avoided, and we can produce using fractional crystallization the ultra pure styrene, meeting all the specifications. If you are interested in more details about this fractional crystallization. In our booth, there are brochures available. You can go through that and have idea. This is already a commercialized step for other application. And this crystallizers are from Sulzer. As you know, Sulzer has acquired GTC in last year, and after this acquisition, all those technologies are merged, and this innovation which I am presenting to is right now. Next slide. So with this step, the advantages are lower equipment count because many steps have been removed, lower capex, lower opex. The electricity can be replaced if we can use ethylene from the cracker plant as cold source for crystallization unit. A smaller plot area, opportunity to relax operation of DC8 and other operations, phenylacetylene HDT as well as EDC. We can operate at relaxed conditions because most of the impurities will be taken care by the crystallization. Ultra high purity product, lower sulfur specification for styrene product can be guaranteed subjected to the neat feed sulfur. The purification section design with crystallization is commercialized. This purification section is already commercialized for different application. It has no moving part, no filtration of crystals, no use of solvents. It's very simple and well proven step for crystallization. Thanks. And next slide. This styrene recovery fits well into naphtha complex where we can take out the styrene, C8 cut, recover the styrene and recycle the raffinate to the first stage hydrotetra. And this recycle will bring the advantages of catalyst life extended. Because styrene has been recovered, hydrogen consumption reduced to half. Styrene quality improved to from solvent grade to xylene mix PX grade, and high value of styrene monomer is there. So all these advantages contribute significantly to the economics of this by integrating the styrene in a cracker complex. Next slide. If you see this curve indicates that there is, despite of volatility in price of crude, there is a volatility in the price of pi gas, but gap between pi gas as well as styrene, it remains quite constant. So it confirms that recovery of styrene is going to improve the refinery margin and margin of operations. Advantages in terms of first stage hydrogenation reactor, you see that temperature at the reactor outlet is reduced with new generation after removal of styrene. At the same time, reactor fresh ratio is reduced from 2.8 to 2.3. Catalyst regeneration cycle increased to 4, and catalyst life 4 to 7 years. So these are the advantages in the operation of hydrotating, which is the add-on advantage because of this, in addition to this price differential. Next. This gives us some typical economics of this styrene process. For a 30 KTA plant, the investment is typically 40 million. Considering styrene production cost at $600 per ton and product price is $1,000 per ton, the simple annual return comes out to be about 30%. And this curve shows the price dip. This is the point where COVID was prevalent, and price of styrene reduced somewhere near 550 and $600 euro per ton, and this was even lower than the production price from EBSM route. but the projections, if you see from the current time onwards, it is expected to be stabilized at about $800, $800 to $900 euros per ton. So that way, extracting styrene from is a profitable venture, as well as
Can we conclude in a minute?
Yes, sure. And it fits well in the current scenario when we are looking for larger refinery margin and integration of refining with petrochemicals. Next slide. So GT styrene technology effective component to world scale naphtha and mixed feed crackers. It is important to keep naphtha crackers competitive. GT styrene provides excellent value for steam crackers, which produces more than 600 tons per annum easily. So this capacity onwards, one can consider GT styrene. Reduced ethyl benzene available as co-product from GT styrene 20. We have 7 licensed units, 3 are in operation more than 5 years. 5 licensed units of 84 KTA will be operational this in Q2 2021, and second generation styrene license award in Europe in Q3 20. Next slide. That's all from my side. If you have any question, these are the contacts available here. Thank you very much.
Thank you very much, Dr. Saxena. Your presentation on how do we make ultra pure styrene by valorizing gas, which will actually we can leverage to reduce the cost of ethylene and propylene coming from a cracker, was very good. This also shows how process intensification is used to valorize the gas by extracting styrene with a novel technology, at the same time getting a high purity product with good yields. Thank you for the presentation.
Thanks.
I think now we have the last presentation for the day. Rajesh, hopefully your technical issues are sorted out. We will have now olefins conversion technology, a sustainable path to propylene. Over to you, Rajesh.
Okay, thank you, Mr. Burton. So, Sunny, are you going to project it, or you want me to try it one more time?
You can try, sir. You can try.
I'll try one more time. And so, going to application window. It's not showing up there. Do entire screen. Are you able now?
Yes, sir. Just allow me a second. I'm just gonna make it full screen. You can just press the presentation button.
Yeah.
There you go, sir.
Tell me when it's ready.
Yes, sir. Go ahead.
Yes, Rajesh.
All right. Yeah. Thank you very much. Sorry for that. Whatever we had earlier. Hopefully it'll work fine now. So today I'm going to talk about the olefin conversion technology, which is basically how to make propylene in a sustainable manner, and how to have the flexibility to make this propylene. So this is a brief agenda that we have. I'll start with the market overview, then we'll talk about the process. And then the big thing is going to be, how is this propylene production, which is on-purpose propylene production, integrated with in a petrochemical complex as well as in a refinery. Then we'll talk about reverse OCD. So just a brief before we delve into the topic, that Lummus technology. Lummus is over 110-year-old organization, and we are a premier licensor of refining, petrochemical, polymers, gas processing technologies. We do supply of catalysts and proprietary equipment as well. We offer over 130 plus technologies, over 2,400 licensed units, lots of patents. The big change that happened to us was this year, as of July 1st, Lummus was acquired by the Chatterjee Group and the Iran Capital. And now we have become a standalone technology licensing organization. So you can see our logo also looks now different. Okay, a quick market overview now. So we're going to talk about propylene. On the left side, in the chart that you would see the projected projected consumption of propylene and future demand of propylene. The blue bars, they show that production of propylene, where the propylene is coming as a co-product from other processes. The green lines are showing the on-purpose production of propylene from different routes. In spite of COVID, the experts are predicting that the demand will come back, and they're saying about 4% post-pandemic growth for propylene. There will be heavy demand for propylene products. It's finding more uses, different kinds of polymers of polypropylene in automotive, renewable. So the demand is there. Now let's look at something about the price history, because here we're going to talk about production of propylene from ethylene. So this is very important, the price history of propylene to ethylene. You will see that the blue line that shows the price history in the North American market, and all the other lines that show the rest of the world in Asia. So you can see actually mostly in the rest of the world, the price of ethylene has always been higher than propylene. In US for quite some time, last few years, ethylene is more depressed than propylene because of the advent of cheap availability of ethane coming from the shale gas and the ethane crackers which are coming up. So there is a lot more ethylene that depresses the price of ethylene. So propylene to ethylene ratio is high. But this is an important factor for determining the applicability of this process. So now let's talk about the differentiation between the on-purpose technology versus the co-production. So in co-production, you have ethane cracking, naphtha cracking. You can have a high olefin FCC unit such as our INMAX unit, or methanol to olefin, which is just like a cracker in a way. So all these processes will create significant amount of propylene, and because propylene here happens to be, really speaking, a byproduct, you can see on the right hand side graph that the cost, the relative investment cost per ton of propylene produced is quite significantly high. As opposed to that, let's talk about the on-purpose technologies. So out of which the biggest one is what we call as CADOFIN, that Lummus offers, which is a propane dehydrogenation technology. So that actually gives a very high yield. You can see it gives 75+% yield. As opposed to that, all these byproduct technologies, they have yield much less than 25%. If you go to OCT, the yield is even higher. And there is another version of it which we'll talk about, which is ethane dimerate OCT. But ultimately, what you find is that for the on-purpose technologies, the cost of the investment cost per ton of propylene produced is significantly lower. Now, OCT is a commercially very well accepted technologies with 52 licensed plants. There is almost 10 million tons of propylene capacity using C4, C5 feedstocks together with ethylene for production of propylene around the world. You can see that vast majorities of those are in ethylene plant, but there is over 20% in refinery applications as well. Majority of the units are, really speaking, in China and Far East and Middle East. There really hasn't been this an OCT unit in India yet, but hopefully the time would be right now. The capacities of these units range from 50, which is like at low end, and the 750 is the largest size OCT unit that we have designed. So a process overview. Process is actually very simple. It is the standard metathesis process where you are reacting normal butenes with ethylene to make propylene. So a C4 plus C2 makes 2 C3s. And among normal butenes, the reactive one really is 2-butene. But what happens in the process, 2-butene, 1-butene, there is equilibrium. So as 2-butene gets consumed in the process, 1-butene isomerizes to 2-butene under equilibrium, and you can drive the reaction. So the feedstock is basically, whether it's 1-butene or 2-butene, although 2-butene is in a way preferred. So there is another version of it, which is a C5 metathesis, so in which you can also react normal pentenes with ethylene. So a C5 plus 2 ethylenes, a normal pentene C5. That'll make 3 molecules of propylene. Isopentene will also react with ethylene, but there will be a byproduct of isobutene. So OCT actually is a very simple process. The first step is the purification of the feedstock. So it's a catalytic process. So some of the bad actors such as sulfur, moisture, and some of the highly olefinic components, diolefinic components have to be brought down in concentration. So that's the first step. The second step is just the reaction that we talked about. And then the third step is separation of the products. And that's also a very simple step, essentially two distillation columns in which you are separating the C2s from the C3s and C3s from the C4s. And C2 is recycled, C4 is also recycled with a purge of some of the heavier byproducts which are produced. So here, if you just look at the fundamentally this process, there is very low energy consumption in this of the process itself, because all other processes for producing propylene, they require some kind of cracking, whether you look at steam cracker, FCC, or even the dehydrogenation. So there you need to provide a lot of energy, but here this metathesis process is essentially energy neutral between the feed and the product, because really what you have is you are making propylene, there is no propane, so there is no super fractionation which is required, and you can produce very high purity polymer grade propylene easily. It's a low pressure, relatively low temperature process, simple process, so few equipment and all predominantly carbon steel metallurgy, which helps having a lower investment cost. Now let's talk about how this process can be integrated with a cracker. So this is just a typical naphtha cracker configuration that I've shown. From naphtha cracker, you are producing your light products, which has ethylene and propylene. Then you have raw mixed C4. Typically, I mean, you will, most of the time, you will have a butadiene extraction, and then the raffinate one from that. Many places in the world, I mean, you will do the removal of isobutene. People will do that. MTB is one of the examples. Then the raffinate 2 is returned back to the ethylene plant. Oftentimes it's hydrogenated and then returned back. And same kind of thing happens with the C5s, that the C5 pi gas, you are doing hydrogenation of that and you're returning that back to C5 to increase the production of the ethylene and propylene. So now let's see how this can be modified with an OCT. And this is the next slide. So what you can see on the red, so you're taking the ethylene, part of the ethylene, that's the feed, and you are feeding that to the OCT unit. The raffinate 2 that you had, that is feeding the OCT unit, which is basically, butene, normal butenes. And some of the C5s you will also send to the OCT unit. So here, both C4s and C5s will react with ethylene to make propylene. And any of the byproducts, they can be recycled back to the naphtha cracker. So you can see it's really speaking a simple add-on to the existing naphtha cracker. Now, this is something important I want to point out to you. So let's look at typical low severity ethylene, naphtha cracker. The P2E ratio, propylene to ethylene ratio, will be like something like 0.65. So that would be your base case. That's what's making in the cracker, and that's what coming at the in the total complex. Now, if you actually put OCT process, what you can do is you can operate your naphtha cracker at a much higher severity. So that will allow you to go actually with a lower ratio of P2E of 0.5. So a lot more ethylene production. But with OCT, you can bring the ratio back again to 0.65. But what's the advantage? The advantage is when you run a cracker at a very high, cracking severity, the consumption of your naphtha feed actually goes down. And actually some of the high value product at like butadiene and benzene, their production also goes up in at high severity. As opposed to that, now I'm talking another case, you can operate it in the same manner, but what I'm doing is instead of having less consumption, I'm having the same feed going through. So if you do that, it will actually allow you to make higher amount of propylene, ethylene, as well as all the other products. So you can operate in any manner, and it is much more profitable. So this graph shows the specific energy consumption of ethylene plant. So you can bring down the specific energy consumption of ethylene plant with the addition of OCT. This is kilocal per kilogram of ethylene plus propylene produced. And that is again achieved by operating at a higher severity, but reducing either the amount of feed or producing more products. So less energy consumption. It's also going to help you in the lowering your CO2 footprint. This is another one. This is showing the operating margin. Again, the same concept, the same the same two schemes are shown over here. One is one in which you are reducing your feed going to the naphtha cracker, which is then increasing your operating margin because you're making the same ethylene propylene by having less feed. As opposed to that, in this case, you have the same feed, but now you're making more products. So that's why your operating margin is going up. So that's a big advantage with OCT integration, right? Now, I'm coming back and showing you the same base ethylene configuration. Now let's talk about how the dimer OCT can be integrated over here. So the concept here actually is simple. It's the same OCT concept. Here what I'm saying is that now I want to make really significantly more amount of propylene. So what I'm going to do is let's say that I don't have sufficient amount of C4s to do this. If that's the case, I can take some amount of my ethylene, put it through a dimerization process and make normal butenes from this ethylene. And then I'm feeding ethylene, whatever C4s and C5s available, all of that to the OCT unit. That allows me to really significantly increase my propylene production. So let's talk about how much flexibility we have. See, at the bottom of this, it's just showing a steam cracker. So typically, in a low severity naphtha cracker, you will have 0.65 or so propylene to ethylene ratio. You can go to very high severity to go to 0.4. But then if you add OCT unit to this, you can increase this propylene to ethylene ratio by repurposing some of the ethylene to make propylene and using the butenes. Now, in the ultimate case scenario, what you can do is you can literally take all of the ethylene and to make butenes, and eventually consume it all to make 100% propylene. I'm not saying anybody is necessarily doing that, but I'm just saying that in theory, that is also possible. Now, this thing is showing basically it is also possible to make propylene using this route from a ethane cracker. And we do the same thing. We use the dimerization unit and OCT unit together. So the C4s for this are made by ethylene dimerization, and you have the ethylene. So together you can make as much propylene as you want. Okay. Now let's talk about how this process can be integrated in a refinery. So again, the concept is same. All I'm saying is that refinery has, especially FCC of gas and coker of gas, has ethylene, ethane, propylene, and propane in the. So we can use the low pressure recovery of that to separate it from others. So simplest thing would be if you have steam cracker, you send everything to steam cracker. As opposed to that, you can use the low pressure recovery unit to separate the ethylene from there, and you can use the same route. You can go through dimerization and you can, make C4s for that and C2s, and you make with olefin conversion unit, you can make propylene. And these units are also operating currently, and they are showing a payback period, very attractive payback periods of 1.5 to 2.5 years. So you're taking very low value, refinery off gases and converting that to propylene. Both, ethylene in that, and you recover the propylene. So this is like the last one I'm going to talk about, the concept, which is the reverse OCT. So again, instead of doing ethylene, butene, making propylene, I'm starting with propylene and making ethylene and butene. Because why I can do that? Because on the same catalyst, I can do this process because it's an equilibrium limited reaction. So I can just change the operating conditions and go the reverse way. So let's see. Again, starting with the same diagram that we had earlier. So reverse OCT, all you're doing is you are taking propylene or part of propylene and you are making more ethylene. So you can make more ethylene, and what happens is that you actually can also reduce your naphtha consumption. So when would you do that? When your propylene prices are really depressed. If they're really depressed, you can make more ethylene out of it, and whatever C4s you make, you can recycle it back to the naphtha cracker to make more ethylene from that. So the other thing that you could do is, instead of say recycling the C4s back, you can use that to make more butene 1 and butene 2, because it's going to make is it's going to make C4s, the butenes, equilibrium is more favored towards butene 2 than butene 1. But we have this technology for co-monomer production in which it kind of reverses this equilibrium at different operating conditions, which favors butene 1. Butene 1 is a high value copolymer, so you can use it for that as well by doing that integration. Right? So now, in summary, what I'm going to say is the olefin conversion technology is a low OPEX and low CAPEX process to make propylene on demand, an on-purpose technology at in very attractive manner. But I'll say that this, of course, depends on the relative price ratios of propylene to ethylene. Its integration with ethylene plant is very easy. It also has the advantage that it can increase the production with that of benzene and even butadiene, the way the process is kind of configured, and these are the side effects of it. It allows you to reduce the total energy consumption of the cracker and improve the operating margin. And then with dimerization, it gives an additional option that if you are short on the C4s, you can make that C4s by dimerization of ethylene to make even more amount of propylene. In refinery, actually, it is also simple. You can have this process as an add-on to make a very valuable product. This would be like a small niche example of a refinery petrochemical integration. So, and then there is reverse osmoticity. In the reverse osmoticity, the beauty of this is, if you have done some pre-investment to allow you the reverse osmoticity, then you can operate your plant in whichever way, because you never know how the prices of propylene and ethylene are going to be in future. So depending on what it is, you can operate the process in a forward manner or a backward manner and maximize your ethylene or propylene. So, that's all I have. I hope you found that interesting. Thank you.
Thank you, Rajesh. Again, we showed how the process gives ultra low energy and maximization of yield of the target product. Further, there are a number of integration possibilities, configurations are also told. I quickly go to, there are two questions for you. One is asking about that, unlike the competing technologies, which is feed agnostic, here you are dependent on requirement of naphtha, and the energy requirement is coming from naphtha cracker. So these are the two observations. You would like to respond to these two?
Yeah. So, it is feed agnostic. You can very well make it work in a mixed feed cracker as well. And actually, what is happening is that the more you go towards the lighter cracking, which is like whether it's LPG or ethane, your production of propylene really suffers. It goes down as your feedstock to the cracker becomes lighter. So in that case, it is very, very useful. So when I talk about the improvement in the operating margin and reduction in the energy intensity, yes, that is happening for the overall cracker complex, for the amount of propylene that you're producing. Yes.
Thank you, Rajesh. I think we have, that's all questions. We are already 3 minutes, we are short the time. So I will just sum up by telling that each one of the presentation presented various options which are available for technology innovation. That is the new innovations which are coming, small margins, margin improvements, what you can bring to maximize the product demand. So that is a major theme with all the presentations covered. And these are all coming up, upcoming technologies. Hopefully whoever has listened can take it forward by applying in their own configurations. Thank you very much for everybody to patiently listen this, and I hand over back to the host. Thank you.
Thank you.
I would like to thank all of you for taking the time and taking us through the presentations. It has been quite insightful to understand all that happens in refineries and how processes are fine-tuned to ensure the best outcome and the best efficiencies. A big thank you to all of you for joining us today. and for Mr. Bharatan for conducting this session. That brings us to the end of the GRPC 2020. I'm sure each one of you would go back better informed with a renewed sense of pride and purpose for the role each one of you will play in the downstream sector in the years ahead. We hope you enjoyed the information sessions, the exhibitions, and a chance to connect with your peers. Thank you all for attending and have a good night.
Thank you.